Using Git as a source code management tool has become an essential skill for all web developers. Git helps you to manage the code in a project as you develop new features, helps to find and fix problems, and simplifies collaboration with other developers, whether they're in your office or around the world. In this course, we will begin with the basics. We'll learn to install Git and understand its fundamental concepts. Then we'll cover the essential techniques you need to add files to a Git repository, to track changes to those files over time, and to view and compare previous versions of files. Our goal is to become comfortable with the most common actions in Git so that you can use them effortlessly. Let's begin our exploration of Git by gaining an understanding of what it is and what it can do for you. Git is software that keeps track of changes that you make to files and directories, and it's especially good at keeping track of text changes. Let's imagine that you have a document. You start with version 1 of that document. You make some changes to it. Now you have version 2, and you make some more changes, and you now have version 3. Git keeps track of those 3 different versions for you. It allows you to move back and forth between the versions and to compare the different versions to see what changed. Git is referred to as a version control system, or VCS for short. Git's not the first version control system ever created. There have been others, and almost all of them had one primary purpose: to manage source code. Programmers wanted a way to be able to track the changes that they made to computer code over time, as they added features and as they fixed bugs. So they created version control. Because of this, they are also called source code management tools, or SCM for short. The two terms are used pretty interchangeably. If you've never worked with a source code management tool before, you have likely worked with other types of version control. For example, you may have had different versions of files and given them different names so that you could keep track of the versions. So you have a budget that you're working on, and you have version 1, version 2, version 3. So you put a little text at the end of the file name to let you know which version this particular file is. If you're like me, you may have even put final at the end of the file name, then found some mistakes, and you called the next version final version 2, or really final this time. Many applications offer some form of version control as one of their features. For example, Microsoft Word allows you to track the changes that you make to a document. You turn on the Track Changes feature, send the document to someone else, they make changes to the document, and then when they send it back to you, you're able to review their edits as well as see the original version. Adobe Photoshop has a feature called the History. You can bring up the History palette, see the changes that you've made to an image, and move backwards and forwards, applying or removing the changes that you've made. If you've ever worked with a wiki, like Wikipedia, then you've used a form of version control. When someone contributes a change to a wiki page, the editors have the ability to undo that change. They can go back to a previous version if they need to. We call that process rolling back to a previous version. And of course, we've all done the most simple type of version control of all, undo. Control Z on Windows or Command Z on a Mac. It will undo something that we typed or a change that we've made. It allows us to go backwards and even undo multiple changes. These are very primitive examples of version control, and they're no substitute for a real version control system like Git. But they do provide useful metaphors for you to have in your head. They're examples of how to track and view different versions or changes over time, and how to move backwards and forwards in the history to undo or redo those changes. That's what we'll be doing with Git. There are 5 important version control systems that predate Git that I want us to look at. There have been others, but these are some of the most popular and the most influential, and I think that they can help us to better understand Git. The first of these is called SCCS, for Source Code Control System. Now, it wasn't the first, but it was the first to become popular. It was released in 1972 and was developed by AT&T, and it was bundled free with the Unix operating system. Now, Unix was also free, and as a consequence, Unix spread quickly to places like universities, and SCCS went along with it. Universities taught their students how to do version control using SCCS, so when they left the university to go work in jobs, the version control system they were familiar with and that they took with them was SCCS. So you can see why it became very popular. We talked about primitive version control earlier, that you might have a file like a budget, and you would save version 1 of that file, version 2, and version 3, giving them different file names each time. Now, when you do that, you're saving the full document 3 different times. That's not a very efficient way to do it. What SCCS does is it keeps the original document, but then instead of saving the whole document a second time, it just saves a snapshot of what the changes were. So if you want version 5 of a document, you just take version 1 and apply 4 sets of changes to it to get to version 5. That's a much more efficient way to store the changes over time. So SCCS stayed dominant until the early 80s when RCS was developed, Revision Control System. And it just made lots of improvements over SCCS. For one thing, it was cross-platform, whereas SCCS was Unix only. With the rise of the personal computer, it was important to have a version control system that would also work on PCs. It was also more intuitive, had a cleaner syntax with fewer commands, and more features. Most importantly, it was faster, and a lot of the speed increase came from the fact that it used a smarter storage strategy than SCCS. Remember, SCCS stored the original file and then kept track of all the changes to that file that went after it. RCCS flipped that around, so it kept the most recent file in its whole form, and if you wanted to go backwards in time and you wanted previous versions, then you applied the change snapshots to go in reverse. If you think about it, that's a lot faster because most of the time, what we want to work with is the current document. With SCCS, if we wanted the current document and there were 20 sets of changes, you had to pull up the original and then wait while 20 sets of changes were applied. With RCS, we can just bring up the current file and it's already stored in its full state. One of the problems with both SCCS and RCS was that they only allowed you to work with an individual file one at a time. So you could track changes in a single file, but not in sets of files or in a whole project. CVS, or Concurrent Version System, allowed you to do that. Now, the real innovation in CVS is not just the fact that you can work with multiple files. It's the concurrent part, the fact that we can have a place where we can store our code called a code repository, and you can put that on a remote server, and more than one user can work on the same file at the same time. They can work concurrently. With previous versions, only one person could work with a file at a single time. So CVS adds a lot of features for users to be able to share their work and be able to update their file with changes that other people have made and placed in the remote repository. The idea of working with remote repositories was further improved upon with Apache Subversion, or SVN for short. SVN was faster than CVS and it allowed saving of non-text files, like images, where CVS couldn't do that. Most importantly, the big innovation of SVN was that it was tracking not just changes to single files or to groups of files, but actually watching what happened in a directory as a whole, watching files and directories collectively, and actually taking a snapshot of the directory, not just the files. Now, that may seem like a small difference, but it's important. In CVS, you could talk about having version 7 of some file. In SVN, you talked about having that file as it appears in revision 7. SVN was able to track the history of directories. For example, CVS had a hard time if you renamed a file. SVN, though, would track that change with no problem. If you add a file, remove a file, rename it, it's watching the directory as a whole to see what happens and taking a snapshot of that, whereas CVS was just looking at a collection of individually named files. CVS would also update files one at a time as it went to either apply or read back changes. SVN would instead do that transactional commit and apply all of the changes that happened to the directory or to none of them at all. The snapshot was bigger than just the individual files. It was an entire directory or an entire set of changes that were happening to that directory at one time. It's a subtle but important difference. Now, SVN stayed the most popular version control system for a very long time. In fact, until Git came out. But there's one other version control system that I want us to look at that comes in between, and that's BitKeeper SCM. It was a closed source proprietary source code management tool. That means that a company owned it and sold it the same way that Adobe sells Photoshop or Microsoft sells Word. One of the important features that BitKeeper had, and it wasn't the first to have it, but that is distributed version control. Before we get to that, let's talk a little bit more about this idea of being closed source, where all the other ones that we've been looking at for a while have been open source. The community version of BitKeeper was free and had a few less features and some usage restrictions. There was the paid version of BitKeeper, but there was also a community version that they gave away for free. And that version was used for source code management of the Linux kernel from 2002 to 2005. It was controversial to use a proprietary SCM for the Linux kernel because the Linux kernel is an open source project. No one owns it, where the SCM is owned and controlled by a company. So many people objected, saying, well, what if they change the rules in the future? We're going to be stuck using this company's software. Well, guess what? In April 2005, the community version stopped being free, and all those predictions came true. So BitKeeper was never as popular as CVS or SVN, but it's important with the creation of Git because of its connection to Linux. Because in April 2005, when the community version stopped being free, that's the same point at which Git was born. Git was created by Linus Torvalds, and you may recognize that name as the person who created Linux and still drives the development of the Linux kernel. When BitKeeper stopped being free, they needed an alternative for managing their source code. Linus looked around, and he didn't like the other VCSs that were out there, like CVS and SVN. He did like some of the concepts of BitKeeper, but he thought he could do even better. So he wrote a new version control system from scratch, and that was Git. Git is distributed version control, like BitKeeper. We'll talk more about distributed version control in the next movie. It's also open source and free, which is great for us, because it means that people like you and me can download it for free, use it for free, and there's no license fees or anything like that. It also means because it's open source, the community can see the source code and contribute to it. They can submit bug fixes, add new features, all those benefits we get because it's an open source project. It's also compatible with most platforms, like Linux, macOS, and Windows. And it's faster than most other source code management tools, 100 times faster in some cases for some operations. It also has better safeguards built into it to guard against data corruption. We'll talk a bit more about that later. Now, these improvements all worked. Git became a big hit. As people discovered the power of distributed version control, as they got used to all of Git's nice features, Git experienced an explosion in popularity. Now, there's no official statistics on this, but to give you an example, GitHub launched in 2008 as a platform to host Git source code repositories. In 2009, there were over 50,000 repositories with 100,000 users. In 2011, just 2 years later, there were 2 million repositories with over 1 million users. By 2018, GitHub was very popular. It was purchased by Microsoft. And in 2019, there were over 57 million repositories and over 28 million users. So Git has definitely taken off. In the next movie, let's talk about distributed version control and see why that's such an important feature. In this movie, I want to explain what distributed version control means so we can understand why it's such an important feature of Git. In the previous movie, where we looked at the history of version control systems, we talked about SCCS, RCS, CVS, and SVN, 4 of the most popular version control systems of the past. But all 4 of these use a central code repository model. That's where one central place is used to store the master copy of your code. And when you're working with the code, you check out a copy from that master repository. You work with it to make your changes, and then you submit those changes back to the central repository. Other users can also work with that repository submitting their changes, and it's up to us as users to keep up to date with whatever's happening in that central code repository to make sure that we pull down and update any changes that other people have made. Git doesn't work that way. Git is distributed version control. Different users each maintain their own repositories instead of working from a central repository. And the changes are stored as sets or patches, and we're focused on tracking changes, not the versions of the documents. Now that's a subtle difference. You may think, well, CVS and SVN, those track changes too. They track the changes that it takes to get from version to version of each different file or the different states of a directory. Git doesn't work that way. Git really focuses on these change sets and encapsulating a change set as a discrete unit, and then those change sets can be exchanged between repositories. We're not trying to keep up to date with the latest version of something. Instead, the question is, do we have a change set applied or not? So you might say that you merge in change sets or you apply patches between the different repositories. So there's no single master repository. There's just many working copies, each with their own combination of change sets. Let me give an illustration to make this point clear. Imagine that we have changes to a single document as sets A, B, C, D, E, and F. We're just going to give them arbitrary letter names so that we can help see it. We could have a first repository that has all 6 of those change sets in it. We can have repository 2 that only has 4 of those changes in it. It's not that it's behind repository 1 or that it needs to be brought up to date. It just simply doesn't have the same change sets. We can have repository 3 that has sets A, B, C, and E, and repository 4 that has A, B, E, and F. None of these repositories is right, and none of them is wrong. No one of them is the master repository, and the others are somehow out of date or out of sync with it. They're all just different repositories that happen to have different change sets in them. We could just as easily add change set G to repository 3, and then we could share it with repository 4 without ever having to go to any kind of central server at all. Whereas with CVS and SVN, for example, you would need to submit those changes to a central server, and then people would need to pull down those changes to update their versions of the file. Now, by convention, we often do designate a repository as being the master repository, but that's not built into Git. It's not part of the Git architecture. It's just a convention that we say, okay, this is going to be the master repository and everyone is going to submit their changes to this repository. And we're all going to stay in sync from that one. But we don't have to. We can actually have 3 or 4 different master repositories that have different versions in them, and we could all be contributing to those equally and just swapping changes between them. Now, because it's distributed, that has a couple of advantages. It means that there's no need to communicate with a central server, and that makes things faster. And it means that it's not necessary to have network access to submit our changes. We can work on an airplane, for example. And there's no single point of failure. With CVS and SVN, if something goes wrong with that central repository, that can be a real showstopper for everyone else who's working off of that central repository. With Git, we don't have that problem. Everyone can keep working. They've each got their own repository that they're working from, not just a copy that they're trying to keep in sync with some central repository. It also encourages participation in forking projects. And this is really important for the open source community because developers can work independently, they can make changes, they can make bug fixes, feature improvements, and then they can submit those back to the project for either inclusion or rejection. And if you're working on an open source project and you don't like the way that it's going, you can fork that project, create your own version, and take it in a completely different direction. That becomes a really powerful and flexible feature that's well suited to collaboration between teams, especially loose groups of distributed developers like you have in the open source world. Distributed version control is an important part of the Git architecture, and it's important to learn about it, especially if you have previous experience with other version control systems like CVS or SVN. We'll talk a lot more about how Git tracks and merges these sets of changes as we go forward. For now, just make sure that you understand that there is no central repository that we all work from. All repositories are considered equal by Git. In this movie, we're going to learn how to install Git on the Mac operating system. Now, if you've bought an Apple computer recently, the odds are very good that Apple has already pre-installed a version of Git. It comes with modern versions of the software. Even if you have that, we still want to install our own version. We want to have a newer version that we have control over and that we can use and we can upgrade over time as well. So the two versions can coexist with no problem. There are 2 ways we can use to install a new version. The first is that Git has an installer we can use, and the second is that you can use Homebrew. If you want to use the Git installer, then you just need to go to the main Git website, git-scm.com. Remember, SCM stands for Source Code Manager. That's the main Git website. We can find out all sorts of information about Git, and there's a link that'll take you to download the Mac software. That's git-scm.com/download/Mac. From there, you can download and run the installer program. I'm going to walk you through those steps. But before I do, I just want to mention that if you're familiar with using Homebrew already, it might be easier for you just to use Homebrew to install Git. It's as simple as typing brew space install space Git, and it'll install the latest version of Git using Homebrew. Now, that's mainly for users who are already using Homebrew. If not, you don't need to worry about it. Instead, we can use the installer. Here I am at git-scm.com. You can see here's a quick link to take me straight to the Mac page, or I can click on Downloads, and then from there I can choose my operating system, and then it says download is starting. Now, if it doesn't actually start, you can click here to download manually, and you see it takes me to the SourceForge site, and it will start my download after a certain number of seconds. You can choose where you want to download that file. You can save it to whatever location you like, in your downloads directory or to your desktop. Now, I've already downloaded that file, so I'm not going to download it again and make you watch me do that. I've got it here on my desktop. It's a disk image, .dmg is the kind of file. So when I open it up, it's going to mount that disk image, and then inside, you'll see the installer right here, .pkg. That's the installer for Git. There's also a README here. It talks about how to uninstall Git and also has some troubleshooting information. Let's go ahead and just open up the package, and you'll see that a security warning pops up. This is a security warning from Apple saying, hey, this is not a developer that we work with. So we've flagged this as being something you should watch out for. And it doesn't want to let you open it. It's a little bit annoying. But if we feel comfortable that we can trust this package, we have another option, which is you can hold the control key while you click on it and choose Open with Installer. And when you do that, it bypasses that security check. It allows us to open. We can click Open. And now once it opens up, we have a guided tour for getting installed. So let's click Continue. Tells us how much space it's going to take up. We're going to keep the default install location. It wants my password. I'll put that in. And then it goes through and it installs for us, just like any other installer. Doesn't take very long. When we're done, we say Close. Now, we have this open here. We probably want to go ahead and get rid of that disk image. I'm just going to open a new window, and you'll see that it appears as a device here. And I can click the Eject to eject that disk image device, and that actually gets it unmounted, so it's not being used anymore. So let's see if it worked. I'm going to go into the terminal, but I'm going to get there by going the long way. Inside Applications, inside Utilities, you'll find a program called Terminal. That's your command line. I've drug a copy of this into my toolbar so I can have easy access to it. This is our command line program. You can see when it pops up, I'm inside my user directory. And let's just try typing which Git. You'll see it comes up and it tells me where Git is located. And let's type in git space -- version. And you'll see it tells me what version I have, which is 2.21.0. And you can see that's what was over here on my installer. Yours may be different. It's very likely that over time new versions will come out. Don't worry about it. The core part of Git is going to be the same. The different small versions are going to be little features and improvements and bug fixes, not things that are going to really affect your work with Git. Once we have Git installed, then we're ready to start using it. In this movie, we're going to learn how to install Git on a Windows operating system. The place we can go to get the Git software is the main website, which is git-scm.com. Remember, SCM stands for Source Code Manager. So git-scm.com will give us the main website and have lots of information about Git as well as installers for different operating systems, including Windows. Let's go there and take a look. Here I am at git-scm.com, and you can see that it already tells me right down here, latest source code release, download for Windows. So if you just come down here and you click on that, then the download Windows page will come up and it will go ahead and automatically start downloading. And if it doesn't, it gives you a link here where you can click on it. Then you just say save file. That'll save it to your desktop. Once it downloads, we can go to the download folder. And you can see I've already got here. I just downloaded a second copy. I'm just going to open the first copy that I had. So we'll just double click on that. That'll open up the installer. And then we'll just follow the instructions inside that installer. So we'll go ahead and say, yes, we do want to allow it to make changes. Once the setup script opens, then we can choose the next option to accept the license. You can install it wherever you like. I'm going to accept the default place for that. You can say what you want it to install, and you can choose a number of different things. I'm again just going to accept the defaults. And it says that will create the program shortcuts in the following start menu. That's fine as well. So pick the editor you want. I'm going to use the Nano editor as just a simple default. It's one that's easy to use. And then I'll choose next. Then you can choose your path. Do you want to use Git from Bash only? It's the safest choice. Your path will not be modified. Then there's Git from the command line and also third-party software. That's if you're going to be using it from other software, or use Git optional Unix tools from the command prompt. So I'm going to go with its default. And then it says what kind of secure transport layer would you like to use if you're making HTTPS connections. I'm going to go ahead and again accept the default there. It now wants to know what kind of line ending conversions would we like it to use. This will check them out as Windows style, but commit them back as Unix style. That's an acceptable choice. Also, we can check out as is and commit Unix style line endings. It's really up to you. It's a matter of style. I'm going to go ahead and accept the default for that as well. They give us a choice here to either use the Minty terminal emulator or Windows default console. If you're on Windows 10, go ahead and use the default one. If you're using something older, you might want to try out using Minty. And then we can choose next. It gives us a couple of other extra options. We're going to go ahead and just take the default for those. And let's say install. And now it will actually perform the installation of Git for us. So the installer has now finished. We can choose if we want to launch Bash or view release notes here. I'm not going to do either of those. I'm going to uncheck those boxes and just say finish so that we're done with our install setup. Now, if we go to our command line program, that's the console in Windows, take a look at that. Now from here, you should be able to type git space dash dash version, and it should be able to come up and tell you that you have Git installed. If you're able to type Git version and get a meaningful result, then it means Git is installed and you're able to access it from the command line. In this movie, we're going to learn how to install Git on the Linux operating system. The first thing you need to know is where to find Git. And there's a main Git website at git-scm.com. Remember, SCM stands for Source Code Manager. And you can also go direct to the Linux download page by going to git-scm.com/download/Linux. Let's go there now. So here I am on the git-scm.com page. It detects the fact that I'm actually visiting this page from a Mac, and so it offers me the Mac version. But I don't want the Mac version. I want to go to Downloads, and I want to choose Linux/Unix. Now, there's a lot of flavors of Linux. You might be running Debian or Ubuntu, Fedora, and so on. All of them have their own package managers to make it easy to install software. So this page lists all of those different instructions on how to do it, depending on your package manager. So you can scroll down. If you're using FreeBSD, it gives you the instruction that you need to type in order to install the software. So it's going to be different for each one, but it's really simple. You just type in that command. The package manager should go out and get the latest version of Git and install it. After you have it installed, then you can just go to the command line and you should be able to type which Git, and it'll tell you where your version of Git is located, and git space dash dash version will tell you which version of Git you have installed. And it should be the latest version that you saw being installed by the package manager. Now in this course, I'm going to be demonstrating everything on a Mac, but Mac OS X has Unix under the hood. So what I'm showing you is actually going to be Unix, and all of the things that I type in the command line, you should be able to type exactly the same way in Linux. Once you have Git installed, we're ready to start using it. In this movie, we're going to learn how to do some basic configuration of Git in order to get us started. The first thing we need to know is that there are 3 places that Git stores configuration information, and it depends on how widely we want these configurations to apply. The first and broadest is the system level configuration. These are configurations that will apply to every user of this computer by default. Now, each user, of course, can override it with their own custom configurations, but these are the default if they don't. Now, these are configurations that will apply only to a single user, which is going to be most of us most of the time, working as a single user on a machine. So on Unix, that's going to be in your home directory inside a file called gitconfig. On Windows, it's also going to be in your user directory. That's the home directory, and it'll be called gitconfig there as well. If you're not familiar with where your home directory is, chances are it's inside your Documents and Settings folder. And you should find your username there. And inside that username folder, that's where you'll see gitconfig. And then the third place that we can store configurations is on a project by project basis. So in a single project, we can have configurations that apply only to that project. Most of the time, your configurations you're probably going to want in all of your projects so that you're familiar with them and it all kind of looks the same as you move from project to project. But there may be special cases where you want something different in a project. Git provides some commands that we can use to make editing these configurations in those 3 different spots easy. Each of them is going to be gitconfig followed by a modifier that indicates whether it should be at the system level, the global level, or just simply the project level by default. So these are the 3 basic commands. It's always gitconfig, and then you just have to decide how widely do you want this configuration to apply. So what are the kinds of configurations we can set? Let's set a few. The first configuration you want to set using git config, and we're going to use -- global, is going to be user.name. And this is going to be your username. I'm going to put it in quotes. Mine is going to be Kevin Skogland. Of course, yours will be different. This will tell it that for this user account, the username for Git should be Kevin Skogland. And all the things I do in Git will have my name associated with it. It's also a good idea to include your email address as well. So I'm going to have user.email, and then I'll put in someone@nowhere.com. You, of course, would put in your real email address. Now I can type git config --list, and it will list all of my configurations. You'll see that there's a lot in there, a lot that I haven't set yet. These are the system defaults. If we hit space so that we can see them all, you'll see that at the bottom, you can see the ones that I have overridden with my name and email address at the end. So these are all of the different configurations that apply. We can also look at a single configuration using git config user.name. It'll tell me my username or email to see what my email is set to. Now let's go see where that file is. Now, it's going to be in my user directory. I'm already in my user directory, but I could also change there in Unix or Linux or Mac OS X using cd space tilde. Now, in that directory, I'll list the contents, and you'll see right up here is git config. If we take a look at what it's inside git config, you'll see that it has just a very simple file. Here's the user settings, here's name, and here's email. You can also edit this file directly. You don't have to do it using the config commands. You can edit the file. The config commands make it pretty easy. There are a couple more that I want us to set. Let's set the editor that we want to use. From time to time, Git is going to want to pop up and open an editor for us to be able to type some text, mostly to be able to type messages that we want stored in Git. So we could, for example, type git config -- global, and then core editor is the configuration name. And then in quotes, you can put the name of the editor that you want to use. So you could have notepad.exe, for example, if you're on Windows. Or if you like to use Vim or Emacs, those are options. If you like TextMate, you can use Mate, and you can supply some options after it. WL1 is, I think, one of the recommended options for telling it to pause and wait before it proceeds. And I'm going to be using the Atom text editor. It's a popular cross-platform text editor. So I'm going to type Atom space -- wait, and that'll just tell Atom to boot up and then wait for Git to tell it what to do as a next step. So put in whatever preferred editor you want there. You can also look up the different settings that people recommend for a choice editor that you have. And git config -- global color.ui, we're going to set to true. Now this probably is set to true by default, but it's a good idea just to go ahead and make sure. This basically says, I don't want a single color in Git. I want Git to be able to colorize the user interface, to give me greens and reds and blues and yellows, and help me to understand different portions of text based on the color. So that's a nice feature that you definitely want to have. So once again, I'll just hit the up arrow to take a look at my git config file. You can see that all of those are now listed. That's my Git configuration that'll apply. There's a lot more configurations you can do. You can refer to the Git website to find out more about them. But these are the central ones you want to make sure that you get: the name, the email, the editor, and make sure that your user interface is going to be able to use color. In this movie, we're going to learn how to install a very useful feature in Git called auto-completion. Now, the instructions I'm going to give you for auto-completion are for Mac and Linux only. And the reason why is because Windows should already have auto-completion installed and ready to go. What autocomplete does, it'll help you to type commands, file paths, branch names, other things like that in Git. Essentially, you start typing a word, then you hit the tab key, and Git then tries to guess based on the context what the rest of the command, the file path, or the branch name ought to be. It can really save you a lot of typing. If there's more than one possibility, then it will let you know that it needs more information, and you can type a little bit more of the word and try again. Git autocompletion is a separate script, and it's included inside the Git source code repository on GitHub. It shouldn't be a surprise that Git uses Git as its source code manager. It's an open source tool. So we can go to GitHub and we can look at the code there and find this autocomplete script. When you go to github.com/git/git, you'll be in the Git repository. If we scroll down, there's a folder here called contrib. I'm going to click on that, open that one up. Inside there's one called completion, and that's where the files are that we want. There's one for bash if you're using the bash shell, which most Unix people probably are. There's also one for TC shell and for Z shell if you've been using those. And there's another one for git prompt, which is something different. Now, if those move for any reason, a good way to find those is just to search up here. If you search for completion, it'll help you to find those files if they get relocated. Let's click on gitcompletion.bash. If we open that up, you'll see that it has some instructions at the top inside the comments telling you what this script does, and it tells us how to use them. To use these routines, you need to copy this file somewhere, and it gives you an example, and then add the following line to one of these resource files, essentially telling the shell that it ought to load this script, that it ought to run this script whenever you open up one of your command line windows. And there's a third step which says you should really consider installing that git prompt script that we just saw on the previous page. We're going to skip that for now. The git prompt is really useful when you're working with branches. We're going to be doing that later, so we'll come back to that later on. But if you want to go ahead and install that now, it's not a problem. So the first step, let's copy this file somewhere. The easiest way to do that is to come up here to the top of the page. If you click on raw, you'll get a text-only version of this file. That's the best thing to copy. You can now just select all and copy paste it into any kind of source code editor. Or We can also just come up here at the top of Firefox and say Save Page As. And then let's pick a location. I'm going to put it in my user directory. So here it is in my user directory. I'm going to call it git-completion. And I'm going to go ahead and put .bash at the end of it as well. Don't worry about putting a dot in front of it. We're going to do that in a moment. Now I'm going to save it. Okay, so now it's saved in that location. Let's go over here and let's take a look. If I am in my user directory and I do ls-la, you see that file here. Now we don't want it to be just a simple file. We want it to be a dot file. One of these files up here that gets loaded automatically and that we really can't see unless we're inside the command line. So let's move that file with mv. I'll hit git and then I'll hit the tab key. And you can see that it auto-completes. Now that's the built-in Unix autocomplete, but that's the same thing we want to set up for Git. We want Git to have the ability to do the same auto-completing. So then I'll put a space, and then I'll put a period followed by git-completion.bash. I'll hit return, and now when I do ls-la, you can see it up here. Okay, so now we've got the script on our computer. Now we need to tell Unix to load that script, to run it whenever we open up one of these windows. So the way we do that is by either adding something to our bash profile or bash rc. If you already have one of those, go ahead and use it. If not, you can create either one. The command that we're going to put in there is a slightly improved version of what that script gave you. They told you just to run this line that says source on it. We're going to encapsulate that in an if statement. So it basically says, if this file exists, then try and load it. Everything inside that square brackets, that's what it's doing. It's saying, does this file exist or not? So this is just a little bit of shell scripting. If the file exists, then load it into memory. So I'm going to open up my bash profile, nano.bash_profile. Again, if you have a RC file, that works just as well. Unix will load both of them. I'm going to drop down here to the bottom, and I'm just going to paste in that text. You can take your time, pause the movie if you need to type it in. But I'm going to paste that in here, and then I'm done making changes. So I want to use Control-X to exit. You see that down in the bottom menu. It says, are you sure you want to save these changes? I'm going to type a Y for yes. And then the name of the file hasn't changed, so I'm just going to hit enter. That's it. Now if I use cat on bash_profile, you can see that it appears there. Okay, the changes haven't taken effect though. I need to actually close this window and open a new one. Once it does, it runs that script. And now if I type git space h and I hit tab, you can see that it completes it with help because it knew that help was probably what I was asking for. That's the command that it had that started with H. If I use a C, there's a bunch of commands that start with C. So when I hit tab, you can see it just kind of flashed at me. If I hit tab a second time, it pops up and says, hey, I've got all these choices. Which one do you want? Let's say I wanted to use the commit command. So I would need to type CO, but that would still conflict with config. It wouldn't know which one of those two I meant. So I need to type COM. And then when I hit the tab, it knows which one. You can see how this can really speed up your typing and may even prevent you from making spelling mistakes. Before we dive fully into Git, I just want to introduce you quickly to Git Help. Git Help is a very useful tool for finding out more information about how to use Git. Once we have Git installed, in order to use Git Help, you just type git space and then HELP. That's it. It'll then return helpful information. So here you can see it has a list of Git commands to be used in various situations. So it gives us some ideas on what we might want to be trying to do. And it also tells us that we can get lists of subcommands and concept guides and things like that as well. And then it gives us a syntax, git help followed by some kind of command that we want to know more about. Let's say we want to learn more about logs and how logs work. Git help log would be what brings up that command. I'm going to just clear my screen so it's easier to see. Git help log, I'll hit return, and you can see that it comes up with a page all about git log. Everything telling us about how it works, the different options we can use. You can hit the space bar to go to the next page, and so on, all the way down till you get to the end. And you can use the arrows up and down as well. When I'm finally done, I can just hit Q to exit out of it. If you're familiar with using Linux or Unix, you may know that there's a command called man, which brings up manual pages for different information. So for example, man space ls will give me information about the ls command that lists directories. I can also type man space git dash log, and that is the same thing as when I type git help log up above. Git help log is essentially bringing up the manual page for git dash log. Hit return, and you'll see it looks exactly the same. So help gives you a convenient interface to be able to access those manual pages to find out more about how Git works. Once you have Git installed and configured, the next step is to initialize Git in a project. The way we're going to do that is with a Git command, which is git space init, I-N-I-T. That's short for initialize. So we're going to initialize a project to use Git using this command. Let's try it out. Now, if we're going to initialize a project, we first need to have a project. So let's create a directory that's going to be our project directory. It can be anywhere you want on your hard drive. Just put it someplace that's easy for you to find. I'm going to put mine in my documents directory. So inside my documents directory, there's nothing in there right now. I'm going to just create a new folder in there, and I'm going to call it first_git_project. So now I want to navigate in the command line to get to that directory. I'm in my user directory right now, so I need to go into my documents directory, and then I can use ls or dir if you're on Windows to list the contents of that directory. You'll see that it contains that first Git project. I want to go inside that project directory. So I'll use cd again, and I'll go inside first Git project. Now I can type ls or dir on Windows, and you'll see there's nothing inside there, which is what we would expect. But I am now inside my project directory. You want to make sure that you're located inside that directory before you actually execute this command. And I'm going to say git space init, hit return, and you'll see it comes up and tells us it initialized an empty Git repository inside that project. And it tells you at the end, it says first Git project .git/. Now, if we look over here, you'll see there's nothing inside there. That's because it's a dot file. These files with a dot don't show up by default. If we type ls-la, that will show it in the listing. So now we see a listing of all the files in the directory, as well as files and directories that start with a period. This invisible Git directory is where Git is going to do all of its tracking. Having that directory lets us know that the Git repository has been initialized and is ready for us to use. In the next movie, let's talk a bit more about what goes inside that directory. In this movie, we're going to talk about where Git stores the files that it uses to do its work. In the previous movie, we created our first Git project, and we initialized that project, and we saw that it created a .git directory inside that folder. Now it's invisible because it's a dot file, but it is there. And if we take a look inside, ls -la and then .git, you'll see that there's a number of other directories and files inside of it. These are the files that Git uses to do all of its tracking. You can see it would use branches to keep track of different branches, hooks, info, objects, refs. Those are all parts of what Git uses. Now, you're not going to need to deal with any of those, except for maybe the config file. If we take a look at that config file at git/config, you can see that it contains some configuration information. Now, we configured some user level configuration before, but we can also configure our project. And if we did, this is where it would store it. So you can use those commands we saw earlier in order to make these configurations, or you can go in and edit the file directly. Really, the rest of it, though, you should leave it alone and let Git handle things. You really don't need to go poking around in here very much. But what I want to point out to you, though, is that this Git directory is all of Git's tracking. If you were to delete this Git directory, Git would be removed from the project. It would no longer be tracking it. There would be no tracking information left anywhere on your hard drive once you throw it away. This directory is the tracking. That's a little different from SVN or Subversion, if you've used that before. SVN puts little files in every single directory. It peppers them out through everything that's tracking. And if you want to remove SVN from a project, you have to go and dig through the files and remove each and every one of those little files that keeps track of things. Git doesn't work that way. Git centralizes everything into this one directory. So if you just see this .git directory, that contains everything that Git knows about this project, and deleting it will erase everything it knows. So in order to track our changes, we first have to make some changes. And since we don't have any existing files inside of this directory, our first change is going to be to add a file. So let's do that. I'm going to do this using a source code editor, not a word processor, but a source code editor. I'm going to be using the Atom text editor. You can also use Notepad or a number of other code editors. It doesn't really matter. We just want something that's going to be raw text and not have all the formatting information of a word processor. So let's create this file and just say, this is my first file. And I'm going to then save that file. And for the save option, I'm going to put it inside that first Git project. And I'm just going to call it first file.txt. Okay, so now it's saved in there. Let's just hide that window and come over here and take a look. You can see that it's in there, firstfile.txt. So now that we've made a change to our project, we want Git to track of the fact that we just made a change. And we're going to do that using git space add, and then a space, and then I'm going to use a period. Period is a shorthand for the current directory. I'm basically saying, hey Git, add all changes that are in the current directory. Now, when we tell Git to add the changes, it isn't actually tracking them yet. It hasn't made those permanent. In order to do that, we need to commit them. So we use git space commit, and then a space, and then we use -m, short for message, and then in quotes, I'm going to put the message that I want to go with it. I'm just going to make it initial commit. So inside quotes, I've got my message. So I'm now saying, oh, okay, all those things that you added and you prepared to commit, now we want to actually commit them and track them forever. So once I hit commit, it comes up and says, yep, you made your commit. It gives me some information about it. This is the basic process we're going to be using over and over again with Git. First, you're going to make whatever changes you want. Then you're going to add the changes and then commit the changes to the repository with a message. Those 3 steps are going to play out over and over again. There's going to be some options and some complexity to those that we're going to learn later on. But the fundamental part of Git is exactly that. Make whatever changes you want, add them, then commit them with a message. In the last movie, we made our first commit, and we provided a commit message to describe what was in the changes that were being committed. In this movie, I want us to talk a bit more about how you write good commit messages, because there are some best practices. The first thing is that you always want to begin with a short, single-line summary of what the changes are. That would be something that's less than 50 characters. If you need to describe more in depth, you can have a blank line followed by a more complete description as well. In the previous example, we just did it all on one line inside quotes. We're going to eventually learn how we can write multi-line commits a little more easily than that. But just know that you always want to start with that single line summary, even if you need to dive into some deeper details. That single one-line summary at the start is important. If you do decide to use a longer description, you still want to keep each line to less than 72 characters. The reason why is that other users who are coming to this repository may be using different devices to view it. They may be viewing it on their computer, on a phone, they may be viewing it through GitHub, or it might be being sent to them over email or being posted to a Slack chat room. So we always want to keep those lines to a reasonable length. It's also a best practice to write your commit messages in present tense, not past tense. This often gives developers a little bit of trouble at first. For example, you would say, this commit is a fix for a bug, or it fixes a bug. You would not say fixed a bug. That's a little bit tricky because you just got through fixing a bug. So when you go to write the commit message, it's tempting to write, hey, I fixed the bug, right? And do it in past tense. But the thing is, the commit message is meant to label the changes. It's a label for what's inside. So what's inside this commit? It's a fix for a bug, or this commit fixes a bug, right? It's not past tense. It's something that's going to label the commit and be used in the future. If you need to make bullet points, typically people use asterisks or hyphens for those. You can also add tracking numbers from bugs or support requests. You can develop a shorthand for your organization. For example, you might begin each commit with what kinds of things are being changed. Is it CSS or JavaScript? Is it a bug fix? Maybe it starts always with bug fix : or maybe everything begins with one of those bug or support request tracking numbers. These types of conventions can be very helpful. And most of all, make sure that your commit messages are clear and descriptive. You're labeling the commit. What's inside of here? You could use something like fix typo, but that's pretty generic. It'd be better if you labeled it with something that was more descriptive, like add missing hyphen in project section of HTML. Instead of using update login code, say what you did. I changed the user authentication to use blowfish. And don't put in extra information that really doesn't have a place in the permanent commit log. So update member report, we should discuss if this is right next week. Well, the thing is, this commit message is going to live on into next year and the year after that and so on. So it doesn't really make sense to write that kind of message. Let me give you an example that demonstrates all of these together. So here we have a sample commit message. The first line is the simple summary. It starts with a ID number, a tracking number. GHI stands for GitHub issue. A lot of people use that. And then it has an ID number for which GitHub issue we're talking about. Then it says fixes bug and admin layout. And then it's more descriptive below that. Now, fixes bug is pretty generic. It doesn't really say a lot about what that bug is, but because I have more below it, I'm going to allow it in this case. And it says when an admin logged out of the admin area, they could not log into the members area because their session user ID was still set to the admin ID. This patch fixes the bug by setting session user ID to nil when any user logs out of any area. That is very descriptive. It really lets us know what's inside this commit, why the commit was made, and what it's supposed to do. Some of these best practices may feel a little bit weird at first, but I think you'll get used to them and find them useful over time. In this movie, we're going to learn how to view the commits that have been made to a Git project using the commit log. The way that we use the Git log is very simple. You first make sure that you're inside your Git project, and from there I just type git space log. And this will return to me a log of all the commits that have been made to this project, with the newest entry at the top. Everything that's being logged is from commit all the way down here to where it says initial commit. That's my message. Let's take a look at some of the other parts. This first number up here we'll talk a bit more about, but it is an ID number. It's a unique ID for every commit. Every commit is given a unique ID so that we can identify it and know which commits we're talking about. Next, you'll see that there's the author. This is information that was pulled from our configuration file. Remember, the very first thing we did when we started the project was we configured it to know who the author was and what the email address was. And that's where it's getting that information. Then we have the date that the commit was actually made, followed by the commit message, which in this case is just a single line, but if it were longer, we would be seeing more of the message below that. Now that's the simplest way that we can use git log. If you type git help log, you'll find out more about the log command, and you'll see that there are a lot of different options that you can use. I'm going to show you just a couple of the most useful ones right now. If I type git log and I follow it with the -n option and then a number, then it will limit the number of commits that it shows me to that number. Now I only have one commit, but let's imagine that I had 50 commits that had been made. Git log -n5 would show me only the 5 most recent of those. Another useful one is to limit them by time, and we can use git log with --since and then equals and then a date. Let's say 2019-0101. So this will show me all commits that have happened since January 1st of 2019. Now that of course applies to my commit. If I go in and I change it to 2020, which for me is in the future, then you see it doesn't show anything. Now I can also change since to be until. Show me everything until that date. So that's everything going backwards. So I can limit it with since and until, and you can use both of them, of course, as well. I can also limit it by the author. Git log --author. And for the author, I don't have to type the full name. I can type any part of the name. So I'm just going to type in Kevin, and you'll see that it brings up that commit. It's actually looking for just the string inside there. Now, if there were several Kevins who had committed to this same repository, then several of them would show up. And then one of the most useful ones is the ability to search for a commit message. I'm just going to clear my screen so you can see it. Let's do git log --grep. Grep is a commonly used term in computers, and it says that we're going to globally search for regular expressions. That's what the GRE stands for. It's globally searching for regular expressions. And so we can put equals and we can put any kind of regular expression we want in there. I'm just going to put the simple string in it, right? That's my initial commit. It's finding init right there. So it'll return any commit that has this string in it. So if I'm looking for all bug fixes, for example, right? Bug fix, right? All the bug fixes would then show up. Or if I want to find everything that's related to a certain GitHub issue, right? I could have all of those show up. That's one of the reasons that it's very important to write good descriptive commit messages, is because then it enables us to go through and search our repository for code related to a certain topic or to a certain feature. In this chapter, we will examine several key concepts in Git, which will help you to better understand how it works. The first of these is Git's 3-tree architecture. Let's begin by looking at a typical 2-tree architecture. This is what a lot of other version control systems use. We have a repository and a working copy. These are our 2 trees. We call them trees because they represent a file structure. At the top is the main project directory, and below that might be 4 or 5 different folders with a few files inside of them. Maybe a few more folders. Each of those folders has a few more folders inside. You can imagine that if you map that out, each of those folders would branch out like the branches of a tree. The repository also has a set of files in it, also arranged as a tree. When we want to move files between the repository or the working copy, we check out copies. That's the term we use. We check it out from the repository into our working directory, and when we finish making our changes, we commit those changes back to the repository. We have 2 distinct trees, because the files may not be the same. Imagine if I check out a copy from the repository. I make some changes to it. I save those changes on my hard drive. Those changes are now permanent. They're saved in my working copy, but they're not yet committed to the repository. My working copy would look different from the repository. Both are saved, but they're in different states. Or you can imagine another case. If the repository is a shared repository and many people are working from it, they may add their own changes to the repository. If I haven't checked out a copy recently, then my working copy won't have their changes. Now that's a typical two-tree architecture. Git uses a three-tree architecture. It still has the repository and the working copy, but in between is another tree, which is the staging index. When we made our first commit in the last chapter, we didn't just perform a commit. First, we used the add command. We added, then we committed. It was a two-step process. We added our files to the staging index, and then from there, we committed to the repository. It is possible to just commit directly to the repository and skip adding them to the staging index. We'll learn how to do that later. But it's important to understand that this is part of the architecture of Git. It's a really nice feature because we can make changes to 10 different files in our working copy and then selectively commit 5 of the changes as one set. That's why it's called staging. We have the chance to add the changes that we want to the staging and then get them ready before we commit them. And we can check out changes from the repository the same way. It's possible to pull them from the repository into the staging index and then from the staging index to the working directory, but usually that's not what we do. Usually we go ahead and pull them straight from the repository down into the working directory. And in the process, the staging index will be updated too. As you're working with Git, it's useful to keep these 3 different trees in mind. There's your working directory, which contains changes that may not be tracked by Git yet. There's the staging index, which contains changes that we're about to commit into the repository. And then there's the repository, and that's what's actually being tracked by Git, the changes that Git has and that it's going to hold on to and keep track of. In the last movie, we gained an understanding of the 3-tree architecture that Git uses. Now I want us to go further with that and look at the workflow that we would typically use when working with those 3 trees. This is the exact process we're going to be using in the next chapter when we work with Git commands. But I think it's helpful for us to begin with an illustrative overview. Let's look at the process. We have our 3 trees. We have the Git repository, the staging index, and our working directory. But to begin with, let's keep it simple, and let's say that we just have a file called file.txt that we've created in our working directory. Let's refer to this set of changes that we've made as A. So it's in our working directory right now. It's not in the staging index or the repository. We know that we can use git add, and that will then add our change set to the staging index. Notice here that I'm using git add and I'm using file.txt after it, whereas before we used just a simple period. The period indicates everything in the current directory should be added. Now I'm just specifying that it's a single file. So just add this one file from the working directory into the staging index. After that, we use git commit in order to push that change set into the repository. Now the repository has the same file and it's the same version as what's in our staging index in our working directory. Now, let's imagine that we're going to make changes to that file. So now we have version 2 of file.txt. We're going to refer to this change set as being B. So once again, we have it in our working directory. When we're ready to add it to our staging index, we use git add file.txt again. It adds it to our staging index. And then when we're ready to add it to the repository, we use git commit and it's added to our repository. Now our repository has 2 sets of changes in it, set A and set B. And then the same thing would be true if we made a 3rd set of changes called C. We would use git add to push those to the staging index and then git commit to push them into the repository. This is the typical workflow you're going to be using to make commits. And then you could use git log in order to view those commits A, B, and C to see what changed between each one. Now, of course, Git doesn't refer to them as changes A, B, and C. It has a unique ID number that it applies to each one. That's that long string we saw in the last chapter. In the next movie, let's talk more about that ID. In this movie, we're going to talk about the way that Git labels and refers to its commits using hash values. In the last movie, we talked about the typical Git workflow and changes moved from our working directory to our staging index and to our repository. I had called these simply A, B, and C. They represented different change sets. In our simple version, they represented changes to a single file. But in real usage, this could be changes to multiple files and directories, all packaged together into a single snapshot. It's a snapshot of changes to our project. Now I called them A, B, and C just to keep it simple, but that's not the way that Git refers to them. Instead, Git generates a checksum for each of the change sets. That's the hash value. A checksum is a number that's generated by taking data and feeding it into a mathematical algorithm. So the checksum converts data into a simple number, and we call that simple number a checksum. You don't need to understand much about how the algorithms work, but you should know that there's a fundamental property that's very important. The same data put into the same mathematical algorithm always returns the same result, or the same checksum. That's why we call it a checksum, because we can check and make sure that it's the same. It's used to guarantee data integrity, and data integrity is fundamentally built into Git because of this. That's not true of all version control systems. The label that Git uses for each one of its snapshots of changes is fundamentally tied to what's in those changes. If you were to change that information, then the label or hash value would change. So each hash value is not only unique, it's directly tied to the contents that are inside of it. The algorithm that Git uses is the SHA-1 hash algorithm. You don't need to know anything about SHA-1 or how it compares to other algorithms that are out there, but you do need to know its name because it's frequently used. People will refer to this value as being the SHA value or the SHA value. So if you hear someone say, what's the SHA value of that commit? That's what they're referring to, is the hash value that's used to label each one of the commits. The number that it generates is a 40-character hexadecimal string. Hexadecimal means that it can contain the numbers 0 through 9 and the letters A through F, and it would look something like this: 5C15E8BD and so on. So Git takes the entire change set to all the files and directories that are being changed, things that have been staged, and it runs them through this SHA-1 algorithm, and it comes up with this 40 long character string, and that's what it uses to label the commit. Now, not only does Git do that with our change set, it also does something else important for data integrity. In addition to using the code that's in each one of our snapshots, it also uses the metadata as well. That means that you can't change the commit message or the commit author or the parent of the commit without also changing its SHA value. That gives us a nice chain of data integrity, because when it goes to generate snapshot A, it takes the parent, the author, the message, and all the code changes, and it generates its SHA value. Then when we make snapshot B also goes through that same process, but it includes the SHA value from snapshot A. So it's linked to A. If we were to change something in A, then A's SHA value would change and B won't point to it anymore. One of the really nice features about Git is the fact that this data integrity of not only our change sets, but also the history of changes and how they relate to each other is built in. In this movie, we'll gain an understanding of the head pointer in Git. Git maintains a reference variable called head, all capitals HEAD. We call this variable a pointer because its purpose is to reference or point to a specific commit in the repository. As we make new commits, the pointer changes or moves to point to a new commit. The head always points to the tip of the current branch in our repository. Now the repository has nothing to do with the staging index or the working directory. It's a way of tracking the current position in the repository. I think a good metaphor to use for the head is the playback and record head on a cassette tape recorder. As we start recording audio, the tape moves past the head and it records onto it. When we press stop, the place where that record head is stopped is the place that it will start recording again if we press record a second time. Now we can move around, we can move the head to different places, we can fast forward and rewind, but wherever the head is positioned when we hit record again, that's where it's going to start recording. The head pointer in Git is very similar. It points to the place where we're going to start recording next. It's the place where we left off in our repository with what we've committed. Let's take a look at some illustrations that will make this clear. In the last movie, we saw how we could refer to them using those SHA values, those 40-character unique values that are tied to the snapshots. I want to distill this down just to make the illustration simpler. And I'm just going to use the first 6 characters of each one of those SHAs. So here you can see the same SHAs linked together as a series of commits. Now, can you guess where the head points to after we've made these 3 commits? It points to the tip of the current branch in our repository. That's the last commit that we made. It's the parent of the next commit that we make. So when we make another commit, it will be attached to the end there after A614B5. That'll become the parent. The head becomes especially important when we start talking about branches. Branches is a more advanced subject we'll talk about later on, but I want to just give you the basics here. By default, the branch we're working on is called the master branch, and that's our main branch. So let's walk through the master branch and see how the head pointer moves as we make our commits. We start with our first commit, 5C15E8. At the start, the the head pointer points to that commit. Then when we make a new commit, it says, oh, the parent is going to be 5C15EA. It runs it all through the hash algorithm. It creates a new commit with a new SHA, and it moves the head pointer to point to that last commit. That's now the tip of our master branch. And then when we make another one, it does the same thing and moves the head pointer again. It's like it moved the record head of that tape recorder in our metaphor. In Git, we have the ability to create new branches, that is to create a new set of code from what we're working on, and it's going to be separate from our master branch. We'll learn how to do that later on, but for now, let's just say that we have a new branch, and that new branch is going to start moving and have its own commits. When we make the first commit, the head moves to that commit. And then when we make another commit, then the head moves to that one, and so on. And of course, we have the ability then to move the head back and forth to different branches so that we can write on different branches, depending on where the head is located. Now, Git will keep track of moving the head around for you. It's not something that you need to worry about, but I do just want to show you where it exists. You'll remember that inside our project folder, we have that directory that's called .git. Inside there, you'll see that there's a file called head in all capitals. It's just a simple file. Let's take a look at what's inside it. Git/head. And you'll see it says ref:/refs heads master. What this is doing is it's telling it that it can find this information in this refs directory. So let's take a look at what's in there. Let's do cat.git, and then let's type in refs heads master, just like it suggests. And look what it comes out with. It gives us a SHA value. What is that SHA value? Well, let's call git log, and let's look at our first commit. Look at that. It exactly matches. So it's keeping track of the head right here in this file. It says, look to this other file, refs heads master, in order to know what it points to. If we switched branches, then the head would point to a tip of a different branch, right? So it's saying right now it's set to the master branch, and the master branch is pointing at this SHA. And there's our SHA right there. You can also see that Git tells us right here in the log that the head is pointing at master right now. So again, most of the time, you will not need to actually manipulate the head yourself. Git will take care of that for you. But it is useful to know about the concept and to understand what Git is doing for you. In this movie, we'll learn to add files to a Git repository. We performed this step once already, but now that we have a better understanding of the Git architecture, we can get some new insights. So you'll remember that we already started a Git project and we put a single first file inside there. And in my command line, I've navigated to that directory. Let's go ahead and learn a new Git command, which is git space status. Anytime we're inside a Git project and we type git status, it'll let us know the status of things. Right now, we're on the branch master. That's always by default the main branch that we're on. And there's nothing to commit. The working tree is clean. We now know what a tree is, and we know what our working directory is, right? So the working tree is that directory of things that we're working that Git is looking at, but are not part of the repository. And the working tree matches what's in the repository. Let's create some more files. You can do that a number of ways. I'm going to go into my text editor, and I'm just going to choose the new file option. And then I'm going to create one that I'm going to just call secondfile.txt. And this is a second file. And then we'll save that. Now let's create another one, another new file, and we're going to call this thirdfile.txt. This is a third file, just something as placeholders that we can work with. Now you can see that my text editor actually is letting me know that these are new files by turning them green. It's working with Git to do that. Yours may or may not have that integration. Don't worry if yours doesn't. It's not important. What's important is how Git handles it in the command line. When we now type git status again, this time we get a different message. And it says we're on branch master, but it says now that there are some untracked files. What does untracked mean? Untracked means they're not in the Git repository. Git doesn't know anything about them. If we were to make changes to them now, those changes would not be tracked. So if I go into second file and I change this is a second file, and I changed it to this is the second file, right? There's no record of that change that I just made because Git wasn't tracking it before. So it's letting me know it's an untracked file, and it tells me I can use git add to include it in what will be committed. That moves it into the staging tree. We learned about that before. This is moving a file into the staging tree. There are a couple of ways that we can add these files. We saw how we could use git add and then a period, and that will add all changes that are in my working directory to the staging area. It says add everything that's in this current directory. Or I can be selective and say, I only want to put secondfile.txt in there. That's the only thing I want to add. Or I could also list thirdfile.txt after it, and it would do both of them. Let's just do one for now. So git add secondfile.txt. I'll hit return. Now let's say git status again. Let me clear the screen, and then let's just type git status again so you can see it. Now it gives me another message. It says there's a set of changes to be committed. These are things that are in my staging area. It gives me a message saying if I want to unstage them, there's a command that can do that. And it tells me what the new file is. And it's highlighted in green to make sure that it's clear and separate. And then I still have one untracked file as well. So it essentially moved things from my working directory into my staging directory. And now I'm ready to commit them to the repository. So we can type git commit space -m for message. And then we'll just make a simple message in quotes, add second file to project. Let's look at the output it gave us. This value that's here is a shortened version of the SHA value, the long 40 character string. It's a shortened version of that. It's letting us know that that's how we can refer to this commit. It gives us the message, one file change, one insertion, create mode, and so on. Now let's say git log, and we'll see the log of the commits, and we see our second commit right here. And sure enough, this characters here match up with what's in this up here. Right? It's a shortened version of that long SHA. And the head pointer has now moved, as we would expect. The head pointer has moved to the second commit. Let's clear our screen and type git status again. And you can now see that it's no longer listed as being in our staging area. It's been committed, but it still tells us about that untracked file, which is in our working directory. Let's repeat the process to add this file. Git add third_file.txt, hit return. You can type git status if you want to see that it's moved to the staging area, but we know that it is there, so we don't actually have to check. We can just type git commit -m add third file to project. Now when we type git log, we see our third commit there. We see that the SHA that's listed here is the same thing that gave us abbreviation for here. We see that the head pointer has now moved to the third commit. And we see our history of commits now in our log. We clear the screen and type git status again. Now everything is being tracked. It's all in the repository. It's not in my staging area, so there's nothing to commit. Our working tree is clean. That's how you add files in Git. In this movie, we will learn how Git handles files which have been edited. We already have our first Git project, which has 3 files in it, and all of those files have been committed into our repository. And in the command line, I'm already navigated into that project. If I type git status, you'll see that there's currently nothing to commit. So now let's make some changes. I'll go into my text editor and let's make some changes to the first file, firstfile.txt. This is my first file. I'm going to change it into this is the first file I added to my project. Any modification of the text is fine. Save those changes. Now we come back over here and we type git status again. This time, Git does notice that there are changes. It says changes not staged for commit. What this is telling us is that Git recognizes that this is a tracked file. This is a file that exists in the repository. It's not an untracked file. And it recognizes that the version of this file that's in our working tree is not the same as what's in either the staging or the repository. So it's changes that have not been staged for commit. It tells us we can use git add to add them. And then you can see it says modified. And it tells us what file has been modified. So the process for adding the changes to this file are exactly the same as when we added a new file. What we're doing is adding the changes. It doesn't matter whether one was a new file and this is an edited file. It's a change set that we're adding. So we're going to say git add and then firstfile.txt. Now I'll hit return. Let's clear the screen just so you can see it easier. When I call git status, now this modified file is in our staging tree. It's waiting to be committed to the repository. So now the staging tree and our working directory agree with each other, but we haven't yet committed it to the repository. Before we do that, before we commit it, let's make some more changes to the project. Let's come back over here and let's go to secondfile.txt. This is the second file I added to my project. Save those changes, and then let's go to thirdfile.txt. This is a third file. I'm going to change it to this is the third file, just so it matches the others. This is the third file I added to my project. And save those changes. You have to save the changes for them to take place in your working tree. So now those changes have been saved. You can also see that my text editor is helpfully coloring these in red to let me know that there are edits to these files that are not yet in Git. That's just a nice feature of the Atom text editor that I'm using. If we come back over to the command line though, we can see that same thing if we type git status again. Notice now though, there's the first message, changes to be committed. These are things that are in my staging directory, waiting to go into the repository. And then I have other changes that are in my working directory that are not in either staging or the repository. So I need to stage those if I want to put them in the repository, right? So those three trees again. So let's add the second file. Git add the changes from secondfile.txt. Now let's clear the screen so you can see it easier. Git status. You can see now those have moved from my working directory into the staging tree, and they're waiting to be committed into the repository. And there's a set of changes that are in thirdfile.txt that are only in my working directory. Let's commit those first two. Git commit -m made changes to first and second files. Now if I type git status, you'll see that there's only that one set of changes that are in thirdfile.txt that are still waiting. They're in my working directory, but not in staging or in the repository. The other changes have been committed, called git log, and you can see right here in this commit, both of those files were in this change set. We'll learn how to look at those later. For now, just recognize that two files were part of this snapshot that we created and that we submitted as one commit into Git. Not just one file, but two files together. I'll hit the Q just to exit out of that log. And now let's add that third file, git add thirdfile.txt. I'll clear the screen and type git status one more time. So you can see that's now moved into the staging directory. Git commit -m modified the text of the third file. And git status one last time. And now all three of the trees agree again, right? Our working directory, the staging tree, and the repository all have the same files and the same changes reflected in them. So the process of committing edits to files is really the same as the process of adding files, because in both set times, what we're doing is really adding changes. And those changes can be new files or they can be edits. It really doesn't make a difference. We treat them the same way. You use git add to add sets of changes into the staging tree so that then they can be committed to the repository. Let's learn how to view the changes in a file before we make a decision about whether we want to commit them to the repository. To do this, let's first make some changes to our project. First, git project, and you can see I'm already navigated into that project in the command line. Let's bring up the text editor and let's make a few changes. Let's go into firstfile.txt and let's add a couple of lines. I'll put a blank line here. This file comes before the others, and Git is tracking my changes. Okay, so if you don't type exactly what I type, make sure you add at least two there. Let's save it. Let's come back over to the command line and let's type git status. If we type git status, it tells us that there is a change to this file, but it doesn't tell us what the change was. And especially if you're working in a lot of code or something, you may forget what you've changed. You may say, wait a minute, I'm surprised that I see a change in that file. Wonder what changed. Well, if we go back over here, it doesn't tell us. It's not clear what has been changed, but something has. And Git knows what it is. So we just have to ask Git to tell us. We do that by using a program called diff, D-I-F-F. It's a very common Unix program, and it is used to show changes to a file in a common format so that we can see what those differences are. In Git, we're going to do that by using the command git diff. So git space diff, and that's going to call the diff program on our code, on the different versions of the files, and compare them. And it's going to return something that looks like this every time. It's a common format. It's comparing file A and file B. File A is the version that's in the repository. File B is the one that's in my working directory. And you can see it tells me minus, 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 and plus, 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 right? It's telling me about changes that are in between those files. So you can see that what's changed is it has added some lines. It has plus in front of it to let me know that it's added, and they're colored green. Now let's just jump back over here for a second And let's change this. Instead of this is the first file I added to my project, I'm going to say this is the first file I added to the project. It doesn't matter what change you make, but make a change to that first line. Now let's go back over and let's call another diff. We get different output this time. Notice that now there's a minus line as well. It's telling us this line has changed. This was subtracted and this was added. That's a change. A change is removing one thing and adding something in its place, right? So that's how it shows us what the change is. And we can look at them and compare and see, you know what changed? My became the. And in addition to that, these 3 lines were added to the file. So these minuses and pluses are going to tell you whether a line has been removed, added, or changed. And if the file was really long, let's say this was a page of code and it had 1,000 lines in it, it would only show us the lines that had changes to it. We would not see the entire file. We would just see little snippets of text showing us where the changes are. It zooms in and highlights and says, these are the things that are different. It makes it easy to jump right to the changes. Now let's try making changes to a different file at the same time. We're not going to commit those changes yet. Let's go to thirdfile.txt and let's add something here that says Git is really useful. I'll save that. Let's come back over here. I'll clear the screen and let's type git diff again. Now it tells us that it's looking at 2 files. This orange section up here tells us this is the first file, firstfile.txt, and it shows us what's different about that file. And then immediately after that, it shows us what's different about the third file. And if there were other files that were different, it would just list them one after another. It would just keep going through all of the files, zooming right in on those changes and telling us what's different, what lines have been added, removed, or changed. Now we can make a decision about whether we want to commit these changes or not. We now know what they are. If one of these changes is not something we want, we can stop and go back to our project and make edits and then commit just the changes we want. In the previous movie, we learned how to use git diff to view the changes in our working directory. In this movie, we will learn to view changes with our staging index only. When we left off in the last movie, we had made some changes to first file and third file, which we had not committed. And if we go over here and we're in our project, we can then type git status and see those changes, first file.txt and third file.txt. Now let's add our first file.txt into staging. We'll use git add with first file.txt. We're going to leave third file just in our working directory. Now let's type git diff. You'll see that now when I type git diff, it doesn't tell me about the first file's changes anymore. It only tells me about the changes in third file. That's because git diff, by default, compares the working directory against the staging tree. If you want git diff to show you the changes that are in the staging area, which there are there, let's do a clear screen and do git status. And you can see first file is in staging. It's waiting to be committed to the repository. If we want to see those changes, we use git diff, and then after it, we pass in -- staged as an option. So git diff with the staged option is going to show us only the changes that are in the staging area. It doesn't show us the ones that are now in the working directory that we saw before. We're seeing a different set of changes. This is showing us the differences between the repository and the staging, not the differences between staging and our working directory. So it's 2 different things that we're looking at. So this tells us what's in the staged area. I also want to note that staged is an alias for cached. If I do git diff space -- cached, CACHED, that does the exact same thing. And in fact, in versions of Git before version 1.7, cached was the only thing available. Staged was added as an alias because it's much more intuitive and convenient because we're talking about that staging tree. So I'm going to encourage you to use staged, but if you see cached, you'll know what it's doing. Okay, so now that we've got those changes there, let's do git add with third file.txt. I'll clear the screen. Let's do git status. You'll see that both files are now in staging, waiting to be committed. If I type git diff, it returns nothing. There's nothing that is different between my working directory and my staging area. Those are in sync. But if I use git diff and I add that staged option to it, now you can see both sets of changes to first file and third file. Let's wrap things up by just committing those changes. So git commit -m minor text edits. That's not a very descriptive text message, but it'll do while we're learning. And then last of all, let's type git status one last time and you'll see that once again, our working directory is clean. There's nothing to commit. Use git diff when you want to compare the staging tree and your working directory. Use git diff with the staged option when you want to see the differences between the repository and the staging tree. We've learned how to add and edit files. Let's also learn how to use Git to track files when they are deleted. So that we can have some files to delete, let's add a couple more files to our project. I'm going to go into my text editor, and in here, let's just add a couple more files, new file, and I will call this file file_2_delete1.txt. And I'll just save the changes there. And then let's add another one, new file, file_2delete2.txt. Okay, so those show up as being new files. If we come over here and we type git status in the root of our Git project, you'll see they're both listed as untracked files. Now, if I delete one of these files right now, it'll just disappear. No big deal. Git isn't tracking these files. They're not in our repository or in our staging tree. They're only in our working directory right now. So let's add them. Let's do git add, and I'll use the period to say add everything. Git status, you'll see it's going to add 2 new files to the repository. Git commit with a message, adds files to delete soon. Okay, so now those 2 files have been added into the repository. The reason I want us to have 2 files to delete is because there's 2 different techniques that you can use for deleting files. The first technique is to just delete the file yourself. So we come over into our documents, we see file to delete number 1, and we can just simply delete it. Let's say we just drag it down to our trash, and now the file has been deleted. It's moved outside the project, which in Git's terms is being deleted, right? It's no longer inside its project. We could have drug it to the desktop and had the same effect, right? It's been deleted from the project. It's still sitting in our trash, or maybe it's sitting in the desktop or another directory. But when we come over and ask Git about it, using git status, it'll say, oops, it looks like you've deleted this file from the project that I was tracking, right? It's deleted from your working directory. So if we want to commit this change to our repository, then we need to tell Git to add this change. So we'll do it just like we did with an add, but we'll use git rm and then the file name. Now note if I start typing file and I hit the tab key, it auto-completes, but it's not sure whether to auto-complete to file 1 or file 2, right? It keeps track of the fact that there were 2 there. We want to delete file 1, so let's be careful about that. File 1 is the one that we want to delete. It comes up and says it removed it, rm and the name of the file. If we type git status, you'll see that it's now in our staging area as a deleted file waiting to go into our repository. Then we can just commit that change, commit-m, delete first file. Now that change has been made. If we go back into git status again, you'll see that the working tree is clean. Now that's to delete 1 file. We still have a second file in there, which is file to delete 2. And I want to show you a different technique for deleting this file. The first time we essentially moved it out of the project or deleted it by hand ourselves. Instead, we can tell Git to remove it. Let me clear my screen, and let's just type git rm and then the name of that file, which you see is file to delete 2. So file to delete 2.txt. Now the file is still in there, right? The file at the moment has not been moved out of there, but we're just going to tell Git, go ahead and remove it. When I do that, it executes this same remove command. If we look over here, the file is now gone, and it's not in our trash either. It has been removed using a Unix remove command. So it has been permanently removed. It still exists in our repository, so if we needed a copy of it, we could get a copy from there, but the remove that it performed is a little different than when we just moved it out ourselves. But notice now when I do git status, it has already added it to our staging directory. So this is a little more convenient. This allows us to do both steps at once. Instead of going and removing the file and then telling Git to also remove it, we can just do it all in one step. Just tell Git, remove the file, it'll trash it for us, and it will also add it to the staging directory, so then we can commit it. Git commit-m with delete second file. Now that file has been deleted, Git status reports that our working tree is clean, and we come back over here and look and the files are now gone. So if you want to keep a copy of the file around and you just want it outside the project, then drag the file and then tell Git about it. But if you really just want to permanently delete it, it may be more convenient to just tell Git about it and let it do the deleting for you. Let's learn how to track moved or renamed files in Git. There are two techniques for moving and renaming files, very similar to what we just saw when we were talking about deleting files. Let's look at both of these techniques. For the first, we're going to make changes to the file name directly in the operating system, not through the command line. So I'm going to change first file, and I'm just going to change that file name to be primary file.txt. So now it has a new file name. If I come over here and I go into my command line, I'm inside my Git project. If I use git status, it'll come up and it'll tell me that there are now two changes that I should know about. The first is it says the file first file.txt has been deleted, and there's a new untracked file called primary file.txt. It's listing them as two separate events. It's not linking them together as being a rename. It's saying, I see that one file was deleted and another file was added. So let's add both of these to staging as if we're going to commit them. So let's do git add primary file, and let's do git remove rm on first file.txt. So that's what we saw in the last movie. Now let's clear the screen. Let's do git status again. And you'll see now Git recognizes that these two files are similar. Now that they both are in the staging tree together, it recognizes that the files are pretty similar. I think the threshold is around 50%. So if they're more than 50% similar, then it says, there were probably changes to this file. And in this case, the files are actually identical. It's the name that changed. So it says renamed. Right? It lets us know that that's the change that was made. It didn't pick up on that initially, but it does pick up on it as soon as we put it into staging. Now, before we commit this, let's look at the second technique. The second one, like when we're deleting files, we can do directly from the command line. We can rename the file from here. But first, let me mention that moving a file and renaming a file are the same thing, because moving a file to a new file path is a way of renaming it, right? It's the same file, it's just got a different path to it. So we're actually going to use move as the way to rename it. So git mv for short, that's git move, and let's move the second file.txt to be secondary file.txt. Now it has moved the file. And just like when we used rm to delete the file, if we come over here and look at the operating system, you can see the file name has already changed. And if we use git status, you'll see that now it's been added to our staging directory, and it realizes that we were renaming it, right? Moving was renaming, and it did it all in one step. It took care of the operating system side and adding it to our staging area. So it's more efficient to do it with a single command instead of doing it the other way. Doesn't mean you can't do it the other way. If it works better for what you're trying to accomplish, you can do it either way, but this is a little more efficient. Let's go over here to our project and let's just do a new folder. I'm going to call that folder first folder, and let's just drag this into first Git project. And I'm just going to drag third file into first folder, right? So there it is inside that folder. If I come over here and I use git status, you'll see it thinks that I've deleted the file and that I've put it in first folder. Now we know what would happen if I added those to staging, but instead, let's just take this back out for a second. Let's put it back in the main project directory. Let's come back over here. We'll say git, and let's just do move third file .txt, and we're going to move it to first underscore folder and then third file.txt. And then we do git status again. You'll see that now it says that it's been renamed, and it tells us it's been renamed from third file.txt to first folder third file.txt. And sure enough, it moved the file in there. So moving and renaming are synonymous, and there's two ways that you can accomplish it. The command line is more efficient. Let's wrap things up by just committing those changes, commit-m, and I'll make my commit message reorganized file names. In the last chapter, we covered the basics of tracking files with Git. We learned to track new files, to view and capture the changes to files, and to notice when files have been deleted, moved, or renamed. And we learned to use the log to view previous commits and the status command to see the uncommitted changes. These commands together make up about 75% of the work you will do with Git. They are the core actions you will repeat over and over again. In this chapter, I want us to switch from using simple example files to using files that better reflect a real project. You can still hang on to that first Git project that we were working with before. It can serve as a sandbox, a place where you can go if you have questions or you want to experiment. For the new exercise files, You can use one of your own projects, but if you do, I recommend using a copy so that you're free to experiment and make mistakes. Or you can follow along with me. I'm going to be using a project which is included in the exercise files. It's the Explore California website. You can see it right here on my desktop. I'm going to drag this folder into my Documents directory so that it now exists right alongside that first project. If you're using a version from the exercise files, it's also a good idea to make a copy so you always have the original to go back to. Inside the Explore California directory, you can see we have a number of simple HTML files and some folders, as well as some JavaScripts and some style sheets. It is a basic HTML website. To view it, just open index.html with the browser. You can just drag that here into Firefox. You'll see a new window will open, and here's the Explore California website. You can click around, all the pages aren't there, but there's enough of them to give a feel for it. In this chapter, we're going to get familiar with this project, initialize it as a Git repository, and make some edits and commits that are similar to a real-world experience. This will allow you to practice the techniques we learned in the last chapter while giving you some practical exposure to using Git. In this movie, we're going to use Git to start tracking changes inside our Explore California project. Our project already has files in it because it's an existing project, but Git is not being used to track them right now. Git has no knowledge about them, and there's no Git repository established to keep track of the files or the changes. To initialize Git, we need to navigate to the project directory in the command line. So right now you can see I'm still inside that first Git project. So let's use CD to back up a directory. I can use ls to see the different directories that are in there, or dir if you're on Windows, and then I'll use cd to go into the Explore California project instead. I'm going to use ls-la to show a listing of all the files that are in there, including the dot files. You can ignore this ds store file. That's something that the Macintosh uses to keep track of positions in the Finder. Notice that there is no .git directory in this project folder. That's how we know that Git is not tracking this project, because there is no Git directory at the root of the project. And if we were to type git status, Git comes up and says, not a Git repository, or any of the parent directories. That's important because we might be further down in the tree, right? So there's not a Git directory that's right in the current directory, but maybe we're further down into the project. This would look up at all those parent projects and see, is there a Git directory anywhere up above me? It goes to parent directory and to parent directory and so on, all the way to the top of the hard drive, looking for that Git directory. So it's not a Git repository. We're not inside a nested directory of a Git repository. This is not being tracked by Git. So we remember how to initialize a repository, right? We use the command git space init. It then initializes an empty Git repository. Now if we do ls-la, you can see that that directory .git has been added. Now if we type git status, it comes up and it tells us about the untracked files, because now there's a repository and it sees that there's a working directory and the working directory has files which are not in the repository. Let's also try typing git log. Notice that we get an error when we type git log right now. That's because at the moment, the head is not pointed at anything. We don't have a commit yet. So the current branch master doesn't have any commits. There's nothing for it to show. So it says add everything in the current directory to the staging tree. Now, if I type git status, you'll see that there's a long list of files that it's planning on adding. So let's add them. Git commit -m, and it's very common just to use initial commit for your very first commit when you have an existing project. It's not very descriptive, but it just lets us know we're adding all the project files at this point. We're not tracking any changes. We're just taking it in whatever state it is and adding it to our repository. Now, if I type git log, we see that first commit. The head is pointing to a SHA-938C64 and so on, and we're ready to start tracking our changes. Git status now comes up and says, your working tree is clean. Everything that's in the working directory is also in the staging tree and in the repository. Now, before we move on to making changes, I want to make sure it's clear that the Explore California repository and the first Git project repository that we were working with before are completely separate. Remember, all the repository information is stored in that .git folder at the top level of those two directories. So the two are completely separate. You can have as many Git repositories as you want on your computer, and each one will track its changes separately. For me, for example, I develop projects for many different clients. I have a number of different Git repositories on my computer, and when I move into a project directory, I'm automatically working in that Git project and with that Git repository. If I change the directory for a different client briefly, I'm now working in a different Git repository with a different set of changes. Now that we've told Git that it should start tracking files, and we've given it its first set of files that it should track, we're ready to start making edits to our project. In this movie, we're going to start making edits to our Explore California website to get a feel for what real-world edits might look like. To start us off, we're going to edit the 24-hour support number that's down here at the bottom of every single page. So that's in the footer. We're going to change it from 4315 to be 4314. Just a nice simple change, and then we'll take a look at those changes. Let's go over to our project, and let's look at the contact.html page first. If we scroll to the bottom of the page, you'll see that way down here at the bottom is the footer, and there's that number that we want to change. Now, on the contact page, it also has the same number higher up around line 70. Here we go. You'll see for support you should call, and the number exists there as well. So we want to make sure we replace it everywhere. So a good way to do that is to use the features of your code editor when it's opened up as a project and to search globally inside the project for a certain value. A lot of times you can do that by going to find. Here I have find in buffer, that's find in the current document, or find in project, and there's a shortcut there for that. On my text editor, that opens up a window down here. It may be different on different text editors, but we're going to search for 4315, and we're going to use find all right now. It'll go through and search, and it comes up and it tells me all of the places that it found it. Now, most of the time, as I said, it's just at the bottom of the page, but on the support page and the contact page, it also shows up a little higher up in the text. So every time we find it in all of those places, we want to change it to 4314. Okay, and you see my text editor puts the two side by side there, so you can see the change it's going to make. And you want to make sure that we do want to replace all of them, and we do in this case. It didn't find anything that shouldn't be replaced, and we'll do replace all. So once I click replace all, it says, are you sure? Yes, I am sure. It has now replaced them all. Now over here, it's telling me that there have been some edits. I also need to do save all, and that will save all of those files so that the changes are committed to my working directory. So I made the changes, I told all the files to save, now that change has been made. If we go over here and we reload our page, and you'll see this changed, 4314. Now let's go over to our command line and take a look at the changes there in Git. So we'll do git status, and we'll see a list of the changes, all the files that got changed, and we can use git diff to see those changes. We learned that before. Now though, we're seeing these changes in context. It's not our simple example files. We're actually seeing a real working website with these changes. So you can see here's the contact page, and here's the first change. Here's what was removed, and here's what it was replaced with. And it's a long line because that's all one line, right? There are no line breaks there to make it a separate line. So it's showing you the entire line all the way across. Notice that it's got some context before and after the changes. That's standard as well. Let me just hit the space bar to go down to see another change. Here, explorers.html, you can see here's the change, and there's context before it and after it, just so we're kind of oriented and we know where our changes are taking place. It actually is giving me 3 lines before and 3 lines after. That's configurable. It also tells me right here, it says I'm viewing line 129 and I'm seeing 7 lines. Line 129 and I'm seeing 7 lines, right? So this is line 129 here, the first one that says Explore California, and I'm seeing 7 lines from there. That can help us to go and locate it in the original file if we want to. Now, when you're viewing these changes in diff, it's actually using something called a paginator. It's showing me pages of data at a time. I can hit the space bar to go to the next page. I can also use F and B going backwards and F going forwards. Now, right now, you can see that these lines are wrapping. That may or may not be true for you. If you want it to change the wrapping there, you should be able to type a dash and then a capital S and hit return, and it will toggle it between chopping the lines or wrapping the lines. So here you can see now support options, it just trails off and goes way past the edge of the screen, or I can use dash capital S again, and it switches back so that now all the lines are being wrapped. Whenever we want to exit out of the paginator, we can type Q, and we'll be back on the command line again. Let me clear my screen, and I'm going to just show you another option we can use, git diff. And this time, let's provide an option to git diff, which is dash dash color dash words. Notice the difference now in the contact page. Now, instead of seeing the plus and the minus for an entire line, it's showing me only the words that are different. So if you have a long paragraph like that, it can be helpful to zero in on exactly what changed by using that color words option. Now it's very clear. It's just that little bit of text that's right here, all the way down to here. That's what's being changed. It's the same information, just being presented a little differently. I'll type Q again to exit out. Now we are happy with all of these changes, so we do want to commit them all. We've already learned how we can make that commit. In the next movie, I want to show you a shortcut. In the previous movie, we made some edits to our project, but we have not committed them yet. In this movie, I want to show you a shortcut to allow you to stage and commit those changes. We've already talked about how you have 3 different trees: the repository, staging, and your working directory. And normally the process is that you add a file to staging, and then once it's staged there and you're happy with the results, then you commit those to the repository. Now, if you already know that you want to commit everything to the repository, then you can skip the staging step. That's what this shortcut does. Instead of using git add and then git commit, you just use git commit with the -a option after it. Git commit -a is the same thing as git commit --all. We're telling it to commit all the files. Now be careful about that because there's 2 important caveats that go with it. The first is that it stages and commits all changes to tracked files. So it's going to commit everything. That might include extra changes that you've forgotten that you made in another file somewhere else. So be careful about it. You don't want to include too much. The other thing is it does not include untracked files. So if there's a new file that you've added, it would not be included. You would first need to add that to staging and then commit it. So let's go try it out. In our project, we can type git status and we can see a list of the different changes that we've made already. Those are waiting to be committed. Right now, they're just in my working directory. They're not in the repository and they're not in the staging tree. So let's commit them all in one step. Git commit -a, and then we also want to provide a message. So we can either do -m for the message, or we can just add it right after the a. -am, saying we're passing in 2 options, the a option and the m option. And then our message here will be edits support phone number throughout website. Now, because we used the shortcut, it didn't put any of these changes in staging. They went directly to the repository. If we clear our screen and use git status again, you'll see that everything has been committed. If we use git log with the -n1 option, you can see just the most recent commit, and it's that edit support phone number that we just made. By now, we've made a few different commits in Git, so Git is able to track our changes. But what about when we want to go back and review those changes at a later date? That's what we're going to learn how to do in this movie, how to view a previous commit. Let's begin by making a change to our project. I'm on the home page of the project, the index.html, and I just want to scroll down here and you'll see that it says, you'll find something to love. I'm just going to change that to you will find something to love very quickly. So let's go to our text editor, and that's going to be an index.html. And we'll scroll down here past all of the beginning till we get to the text, and it says you'll find, we're going to change it to you will find. All right, let's save that change. Let's come back over here to the command line. We know that we can type git status to see the files that have changed. But we can also type git diff to just see what changed, right? That's showing us everything. We also learned we can use color-words, and it'll then show you exactly what changed. You'll change to you will. Okay, so that's the change that I want to make. Let's go ahead and commit that. Git commit. And we've learned that we can use that -a option with m. And then for a simple message, let's just say changes you'll to you will. Okay, so now we have our commit there. And if we clear the screen and we do git log, we can now see that commit as well. Now, what if we want to go back and we want to look at these commits at a later date? Let's say we want to look and see what we changed here. We see the commit happened, we know what it's about, but what about what's in that commit? What were the changes? The way we are going to do that is we're going to tell Git to show a commit. So git show is the command, and we're going to provide a reference to that commit. And I'm going to use this SHA. That's the ID for each one of the commits. You can copy and paste the whole line, but you don't have to. You can just grab the first part of it, or you can even just type it. 1C16945. That's enough for Git to disambiguate it from the other commits and know which one we're talking about. If we had a huge project that had lots and lots of these, maybe we would need a longer string, but just having 6 to 8 characters is enough for Git to know. So once I hit return, it pops up and it gives me a diff of all the changes that I made. and I'm in that paginator, I can use F to go forward and B to go backward and Q to quit. And it'll show me the changes that I made. If I go back to git log again, let's say I want to see what's in this commit. So I can use git show and then FB74 D33 F8, hit return, and you see the changes. And just like before, if I use git show and I use color words as an option, it gives me just the changes using those color words, just like we did with diff. That color words option works for both show and for diff. So now we have the ability to make commits, we have the ability to take a look at the list of commits that are there, and we have the ability to inspect any one of those commits to find out what changes it contains. In this movie, I want us to learn how to compare two commits. In order to do that, let's make another change and we'll commit the change. Instead of being on the home page of our project, I'm just going to go to our resources page to tour facts. If you scroll down here, it says in this section, you'll find frequently asked questions. I'm going to change this to in this section, you will find frequently asked questions, just to make a small change so that we have something to look at. So I'm going to go to the resources page, and here's the FAQ. And let's just scroll down till we find that text. In this section, you will find frequently asked questions. Okay, so we'll save our change. We'll come back over here to the command line. We know that change is there now. Git status will show it. We can take a look at that change using git diff, and we see what changed. We can use color words if we want to only see that single change. It can be a little easier when you just have a short bit that changed. And let's commit it. Git commit -am. I'm going to make my message remove contraction in text. Now, if I use git log, you can see that I have that new change, remove contraction in text, as well as the one I made in the last movie, which was basically the same kind of commit, but on a different page. What I want to show you is how we can view the differences between commits. Now we know that we can look at any one commit, like I can use git show, and I can type 9DCFF6E, and I can see that commit that I just made. I also can do the same thing for any of these other commits. I can see the commit that's here. But what if I want to compare this commit to this commit? Well, that's the same thing. That's what the change set is. The change set is everything that's in here is what changed from here. But what if I want to compare this commit to one of my older commits? That I can also do using git diff. Git diff, and then the name of the oldest commit, which is this one right here. I'll just copy this first little bit and paste it in. Then ... and then the ending commit that I want to go to. I'll copy that and paste that. Now I'm asking Git to create a diff file, not of the changes that are in my directories, not show me what's in a commit, but compare two different versions and show me what changed between them. And you get what you would expect. We have two changes, one to index.html and one to the FAQ. And if I use color words here, you can really see it, right? There's the first change. And then if I use the down arrow, you can see there's the second change. So what I'm seeing is two different change sets. I'm seeing what's in this change set and this change set. It's allowing me to compare this commit to this one. This is a handy tool, and eventually you'll be able to use it to compare commits between different branches, between different tagged versions, all sorts of ways that you can refer to different commits that are in your repository and compare them to see what changed. One last thing I want to show you before we leave this is that because this is called head, I also can refer to it as the head. So if I just hit the up arrow, and instead, let's go back and erase this commit name, and let's just put in head. Head will always refer to the latest commit, right? That's the thing that it's pointing to at the end, and you see I get the exact same results that way. So either way, whether you use the long version and write out the SHAs, or if you use the shortcut and just use head, which we know points to the same thing. It's a very handy tool for being able to see the differences between code at different points in time. The commit messages we've been putting in so far have been single-line commit messages. I want us to spend a moment just to see how to make multi-line commit messages. Let's begin by making a commit. We're going to make a change to the Explorers page. So let's just go into our project and let's open up Explorers. And on the Explorers page, let's scroll down to the text and let's make a few edits. Let's imagine that the client has sent us a list of edits that they want us to make. So they've said, We want to change this from best of all, comma, joining is absolutely free. And so what can you do? They want to remove this. So it just says, what can you do? And then let's change this. Let's scroll down a little further. Let's make this you will receive, special members only. And let's scroll down a bit more. One more thing, ... Oh yeah, one more thing. Let's remove this oh yeah and just make it once, capital O. Once you join, you will receive our super secret decoder ring. Okay, so these are the changes that the client has asked us to make. So we'll save the file. We'll come back over here and we're ready to make the commit. So git status, we can see the changes were there. We can use git diff if we want to take a look at what the changes were. We can review them. But once we've done that, then we're ready to commit them. We already know that we can type git commit, and we learned that there's a shortcut. We can use the -A option to commit everything without first submitting it to staging. If we also want to have it provide a message with it, normally we've been doing an M option and then in quotes putting whatever that message is. If we instead leave that option off and we just tell it commit everything, it still needs a commit message. So it's going to ask us for one, but it's not going to get one in this single line. So just try it with me, -A and hit return, and it says waiting for your editor to close the file. It may take a second. It's going to then go to your text editor. It's going to open up, and you can see that the name of the file here is commit edit message, and it's waiting for me to type. It gives me some instructions. Please enter the commit message for your changes. Lines starting with the pound or hash sign are going to be ignored, and an empty message aborts the commit. So if I don't do anything, it's just going to abort the commit and it won't happen. But I can type my message here. So I can say text edits. Let's change it to be minor text edits. I have the ability to sort of massage this till I get something I'm happy with. Then I'll skip a line. That's good convention. Skip a line after the main text message. And then I can type some more things. I can say client emailed changes to the Explorers page. Okay, so that's it. Now I'm just going to save that file and close it. And as soon as I close it, if we jump back over here to our text editor, you'll see minor text edits is the name that it gave it. Git log, minor text edits, client emailed changes to the Explorers page. See how it listed those? Now, why did I do two separate ones? Now, watch this. If I do git log space -- one line, now it gives me the log and it only gives me the first line of each one. It gives me a condensed version. So here's the minor text edits. The second part of it gets suppressed. Client email changes to the Explorer page. I just see the single one. But when I just do by default that git log, then I see everything. I see a much longer explanation of what's going on. So that's all there is to providing multi-line text messages. You just do a regular commit, but you don't use the -M option when you're doing it. And if Git knows what your default text editor is, it'll pop that text editor open and wait for you to provide the text there. In this movie, I want to talk about making atomic commits. An atomic commit is essentially just a small commit. That's where it gets its name from. Being very small, the fundamental building blocks of matter are atoms. So we want to make our commits as fundamentally small as we can. Now, it doesn't just mean make them small, but it also means to have them affect only a single aspect, to have them kind of grouped together by topic so that they relate to one thing. So it's as small as possible and related to one thing. This makes our commits easier to understand when we look at them. They're easier for us to work with and easier for us to find bugs inside of them. A commit doesn't become this huge mishmash of all sorts of changes. They become very well labeled sets of commits so that it's easy to find things. It's also very useful when you start collaborating with others. Let's imagine that I have a repository and I make a couple of changes. And then Mary in my office is also working on the project, and she would like to incorporate a couple of my changes. Now, she doesn't want all of them. She just wants the changes that are related to a certain feature. If I have atomic commits, she can use Git to just grab those commits and bring them into her project. If we have a big mishmash and I have one commit that has 50 different kinds of changes in it, then she can't. If she brings in that commit, she'll bring in all 50 changes along with it. Let me give you an example. Let's imagine that we get an email from our client for Explore California, and they want us to make some changes to the tours page. You see, right now it says Backpack Cal is the name of this backpacking adventure you can take. And if you click on Learn More, it takes you to more information about Backpack Cal. But the file name here is just tour detail backpack.html. And the client has decided for some reason they don't like that. They want it to be more specific, and they want it to be called tour detail backpack_cal. Maybe they've decided it's part of their branding and it's important for that reason. We're not going to question why, but we're going to make that change for them. So we'll go into our text editor and we're going to find the tours page. We've got both the regular tour and then the actual file here, tour detail backpack. We can rename that file in the Finder, but we also know that we can rename it from the command line, and that's a little more efficient. So let's do that. Git, move, and then inside tours, and then slash, and then we have tour detail backpack.html, and we're going to change that to be exactly the same name. I'm just going to copy the whole thing, but this time we're going to change it to be _cal. So now I say git status, and you can see that it renamed the file. And if I come back over here, you can see the file has been renamed as well. Okay, that's great, but you probably know from working with HTML files that if we change the name of the file, we have to change all the links that point to it as well. So let's find all the places in our project where that link occurs and change them. I'm going to do that with another one of my global finds, find inside project, and I'm going to look for backpack.html. Let's do find all. It searches and it found a couple of them. Now I'm not going to change it to 4314. I'm going to change it to backpack_cal.html. So it's going to change all three of those links. I'll use replace all. Are you sure? Yes, I'm sure. And then I'm going to use file save all to save all of those changes. Now if we come back over here, we type git status, you can see that it made those changes as well. Okay, now the client also had another instruction for us at the same time. Not only do they want us to change that, they want us to come over to this contact page and make a couple of changes on this page. They wanted to remove the contractions that are in here. So let's go through and let's switch to the contact page. Here it is, contact.html. I'll close my search window and let's scroll down to the text. And let's say, if you are on this page, we are guessing you have got something to say, drop us a line. If you are looking for our seasonal tours, when you are thinking of taking a trip, and we will be sure to throw in some cool discounts. We don't publish these for everyone. Let's say we do not. Okay, that's enough. We won't go through and do all of them. We'll just change them from that first paragraph. All right, so let's save this file also. I can close this find window that's back here. And let's go back to the command line. Clear the screen. We'll do git status. Now I have some changes. So I could commit all of these changes, right? Now, if I just do a simple commit, it's only going to commit what's staged. If I did a commit with the -a option, it would commit everything, both what's in red and in green. But these are kind of two separate sets of changes, right? One set is related to the tours and the renaming we did there, and the other one is text changes that they wanted to the contact page. I could do them all as one commit, and there may be times when it makes sense, where you just want to say, these are all related in some way, and I want to commit them all together. But again, think about if someone else comes to this, if they wanted to just look at a single commit, or they wanted to grab that commit and use it in their project, if I put them all together, they would be forced to take the changes all together, right? They become one package of changes. If I want them to be separate and I want them to be atomic, then it's better for me to separate them. And that's where that staging area is really useful. I can say git add tours, and I'll use the HTML file first, and then git add tours, and I'll just put the slash for everything that's in the directory. Now when I say git status, now the things that are in tours are going to be committed from the staging area. The changes in contact are just in my working directory. They're not being staged yet. I now have an atomic commit ready to go. Now before I commit it, I just wanted to point out one more thing. Notice we renamed this file from backpack.html to backpack_cal.html. We also made a change to a link on that page. Notice that it combined those here. So when we're renaming a file, all of the minor changes that are in there get folded in as well. Now they're visible if we go and see them. They just don't show up in the staging area. It just says it's renamed, and any minor differences that happened along the way get folded into that line item. Okay, so now let's make our commit. Let's say git commit. We don't want to use the -a option because that would pick up contact as well. We can use the -m option, or we can do the multi-line commit we just learned how to do. I'm going to do a -m, and let's say changes file name of backpack tour and related links. Okay, so that one's there. Now if I do git status again, we still have the contact change that we haven't submitted yet. Let's do git commit -a. I'll use the m option, and let's provide a message right here. Let's say remove contractions from contact page. So now if I do git log, we have two separate commits, and each of them is atomic. If I take a look at what's in that commit right there, git show, and then put in the SHA, you can see that it's just the changes that are related to that one thing. And if I use the second one up here and say git show, then you can see that I'm seeing only that set of changes. Making atomic commits is a best practice. And the more you use it and the more advanced you get, the more useful you'll find it. It's time for a challenge assignment. Let's imagine that the client for the Explore California website sends you an email and asks you to make a couple of changes. And the challenge is for you to make those changes and then track them in Git. So the email from the client asks for three things. First, they want you to change the price of the Big Sur retreat from $620 to $750. Second, they want you to change the price of the California Calm promotion from $250 to $270. And third, they want you to change the title of the Explorers page to read Make New Friends. Let's go to the website so we get an understanding of what these changes are going to require. On the Explore California site, there's a number of pages that have these monthly specials listed over in the left column. And you can see that California Calm is listed here as being $250, and Backpack Cal is listed as being $620. Those are the prices that they want you to change. Now, they're not just on this page, though. They show up on a bunch of other pages. If we click on Mission, you can see they show up there as well. So we're going to be changing it in a bunch of places. If we also go to Tours, you'll see, we scroll down here, we have links that take us to Backpack Cal and to California Calm. If we go to Backpack Cal, you'll see on that page is the Big Sur retreat. And it's already listed here as $750. So we don't need to change anything here. Let's hit the back arrow. And under California Calm, we see that that page doesn't exist yet, right? That's just a placeholder for now. So we don't need to worry about that link and where it goes to. But you will need to make sure that you change it globally on all the other pages. So California Calm is going to change to $270, and the Big Sur retreat down here for Backpack Cal is going to be changed to $750. In addition, on the Explorers page, it says come make a few friends right now. They want to change that to be make new friends. Just much simpler and cleaner, just 3 words, make new friends instead of come make a few friends. So that's it. Those are the changes you need to make. They're pretty simple and straightforward. The trick is to make sure that you get them all, then that you are able to commit them, and don't forget to follow the best practices. Make atomic commits, make good commit messages, and don't forget to try the different Git commands that we've learned. Git log, Git status, Git diff, Git show. Try them all out. Get comfortable with them. That's the purpose of this challenge assignment. In the next movie, I'll show you the solution I came up with. In this movie, I'm going to show you the solution that I came up with to the client edit assignment. So the first thing that I did in this assignment was to go and change the different prices. So I did a global search, and I just did a search for $620, and I found all instances of that, and then I changed all of those to be the new price, which was $750. Now, there's not any here now because I've already changed them. And then I did the same thing for $250 and $270, but I had to be a little bit more careful with $250 and $270 because there was another price in there that was $250 for something else, and I didn't want to raise the price on that accidentally. So you do need to be a little bit careful with your global searching to make sure you don't change too much. In fact, if we do a search here for $250 to find all, it still shows up. There's the one that was in there, Tour Detail Backpack Cal. If I click on it, the Death Valley Survivors Trek was also $250. So I want to make sure I didn't accidentally get that one by mistake. Once I had those changes, then I was able to switch over to explorers.html, and change that title from come make a few friends to be make new friends. All right, so we'll save all of those changes. And then if I come over here to Firefox and let's go to the Explorers page as an example, you see it says make new friends, and here's the price. It's been increased to 70, and the Backpack Cal Big Sur Retreat is now $750. Okay, so we've made those changes successfully. Step 2 is to track those changes. If I type git status, then I see a list of all the files that have changed. So I could just do one monolithic commit of all of these changes together. And that is an acceptable solution here. But again, it's better and it's a best practice to do an atomic commit, to group things together. So I would say we don't necessarily need to make the prices into 2 separate commits. We could. There might be a good case for why they need to be separate. I'm going to say that it's enough to just change both prices together and to make the changes to the Explorers page a separate change. So it's 2 commits we're going to be doing. Now you'll notice that Explorers is only listed once here, but it actually has 3 changes to it. We just saw all 3 of them. Let's clear the screen. Let's do git diff and let's do explorers.html. You can see come make a few friends changed to make new friends. And you can see that the price of the day spa package changed. If I hit the space bar or F to go forward, you can see the price of the Big Sur retreat changed. So I don't want those to be together. Now there are some more advanced things you can do in Git to allow you to commit just some of these changes. But when you're a beginner, the easiest thing is to just do them separately. So I'm going to go ahead and just go back into my code. And I'm going to just take this make new friends and I'm going to undo that change for now. Save the file. I'll come back over here to my command line. If I now diff the same file, you can see that there's only those 2 changes in there. Only the price changes. So that other change can wait. Now let's do git add, git status. You'll see now they're in my staging area and they're waiting. Now I can come back over here and I can use undo with the shift key and actually redo the changes, make new friends. Let's save that. Now let's type git status. And you can see there are more changes now in my working directory that are not in staging, but they don't automatically get added to staging. Staging still just contains those price changes. So I'm able to make an atomic commit at this point. So let's do that with git and then commit. We won't use -a because we don't want to include explorers.html accidentally. And let's don't include -m either. Let's do a multi-line message. So I'm going to hit return. It's going to take a second while it opens up my text editor, brings up a place for me to type the message. And my message is going to be edits prices on 2 packages. I'm going to hit return a couple times. I'm going to put an asterisk and I'm going to say Big Sur retreat from 620 to 750 and California Calm from 250 to 270. So now I've listed what those changes are. We'll save it and we'll close that window. As soon as I do, I can come back over to the command line and now git log has that edits prices on 2 packages, has details about what changed, and git status still has 1 more commit waiting to be made. So we're going to make that one with git commit. This time we can use -a because we want to get everything. We can use the shortcut and it's going to be simple. So we use -m and then our quote will be changes title of Explorers page. And that's it. Now git status and everything has been committed. Now all changes have been made and everything has been committed to Git. In this chapter, we will learn different techniques to undo changes in Git. Those may be changes to the working directory, to the staging index, or even changes committed to the repository. Let's start by looking at how we undo changes in the working directory. To give you an example, let's imagine that we're working on a page. Let's go ahead and just open up index.html, and let's say that we've made some changes to the page. Now these might be changes we made on purpose or on accident. What I'm going to do is I'm going to take this site navigation here and I can collapse it down. I'm going to take the entire site navigation and delete it. Maybe I did it by accident, but the site navigation is now gone from this page. I'll save the changes. Let's go over and take a look. We'll reload the page. You can see that it's gone. Well, that's not what I wanted. So how do I get those changes back? Let's say that I've already closed this file, right? The file is completely closed. I can't use undo anymore to get those changes back. But that's not a problem because Git knows what the file used to look like. It's tracking our changes. So if we go to our command line, we type git status, Git knows about the change to index.html. Git diff will show us what the change was. So now we can see that's the text that we're now missing. That's what we'd like to get back. We don't have to just copy and paste that or retype it or anything awful like that. Instead, we can use Git to restore those changes. Let's type git status again. Notice it tells you right here, git checkout space dash dash and then the name of the file to discard changes in the working directory. That's what we want to do. Now, git checkout is a flexible command. We can use git checkout for a lot of different things, especially when we start working with branches later. We'll start using checkout. In order to tell Git that we don't want to check out a different branch, we want to check out a file on the current branch, we use that bare double dash. So it's just space dash dash space, and that's a separator that says, hey, Git, don't go to a different branch. On the current branch, go get me this file, index.html. And what it does is it goes to the repository and it checks it out. Just like it's checking out a library book. It checks it out and it replaces whatever we had in our directory with it. It discards the changes that are there. So it is powerful because it will remove any changes that were there and restore us back to the version the repository has. I'll hit return. Now, if I type git status, you'll see that it says the working tree is clean. If we come back over here and we take a look at the file, index.html, here's our site nav again. And if we come back to the web page, we reload it, our navigation has come back again. It's a handy tool. The fact that Git knows what files used to look like, so we can always go back and ask Git for help if things changed in a way that we don't like. I also want us to see how we can undo changes that we've made to our staging tree. Essentially what we're saying is things that I have staged there, I'd like to now unstage them. That's what undoing things in the staging tree means. Put them back like they were. Make the staging tree match the Git repository. So in order to see this, we first need to make some changes that we can take a look at. So let's go into our text editor. Let's make a couple of changes here. Let's look at index.html. Let's scroll down and let's see, we've got some packages here. We changed prices on packages before. Let's just bring up Taste of California. And let's change this price from $150 to something else. So I'm just going to do a global search for $150. Let's do find all. See what it brings up. There's a bunch of these in here, and let's change it to be $175. And we're not going to make this change permanent in the end, but for now, let's make sure we've got them all, and let's do replace all. Okay, so it's replaced a whole bunch of them. Git status. We now have a whole bunch of changes. Let's now try adding some to our staging area. Now let's don't add all of them. Let's just do git add, and let's put in tours, and I'm going to use asterisk after. That's a wildcard character. You'll see if I use that it adds tours.html as well as tours, which is the directory which had other stuff in it. So it's a good handy way to put in all three of those files at once. So now they're in our staging index. What if we want to undo that change? What if we say, oh, wait a minute, I don't want that. I want to pull those back out again. Well, it tells you right here, use git reset head and then the file name to unstage it. So that's the command we use, git reset. We're resetting it back to the head. That's the current commit, and then the file that we want to reset. So let's just do tours.html to start with. Now if we say git status, you can see that it's been unstaged. We can do the same thing for the other ones. Git tours, and I'll just put the / there. And then if I do git status again, you can see that now those have been unstaged as well. So you can play with it. Try it. Try adding different ones. Try add mission.html. Now we'll see it there. And now we can unstage it with git reset head and then mission.html. Now it's unstaged again. It's that easy. It's handy that Git gives you that information right there in the status command. So it's easy for you if you forget. Once you're done playing with it, instead of committing these, let's use what we learned in the last movie and let's check them all out again. Git checkout and then space dash dash, and let's use the period to say that it's all files. Git status now, and everything has been returned back to the way it was. All our changes have been undone. In this movie, we'll talk about amending commits that are already in the repository. You'll remember when we talked about the architecture of Git, we talked about how those SHA values are generated for each one of our snapshots. Every time we take a commit, Git takes all of the code changes that we're making, as well as the metadata about the commit, runs it through an algorithm, and comes up with that SHA value. And when it goes to make the next commit, it uses the previous SHA value, the parent value in the next commit. So when we generate a snapshot for B, we come up with a SHA value 38E73 and so on. Then when snapshot C needs to have a commit made, all of its code changes, all of its metadata, including that SHA value, get used to generate its value. This is an important aspect of the way that Git maintains data integrity and makes sure that you can't change the history of commits. That has important implications for amending commits, because if I go and try and make a change to snapshot B, whether that changes to the code, changes to the commit message, to the author, or even just to the date, so that the date is today's date instead of the original date, all of those things would change the SHA that gets generated. And that would then break the chain, because now snapshot C won't be pointing at that previous commit anymore. Now, there are more advanced techniques you can use if you really need to make changes further back in the chain. However, they are not easy, simple changes. Git doesn't want you to change those previous commits. However, there's one exception, and that is the current commit, the most recent one, the one that head is pointing to. Here, if we were to make changes to snapshot C, it wouldn't break the chain because it's the last link in the chain right now. There's nothing that's depending on it. So that is the one commit that we are able to edit. Let's see how. Let's go to our website. Let's start by making a change. Let's go to the resources page. You see it says need help planning. And if we scroll down, you'll see that it has tour checklist and it has recommended items to bring on the trip. We're going to make some edits to that list. So let's just hide this for now. And let's go into our text editor. I'll close the search window where we were looking before. And let's open up the resources.html file. And let's scroll down till we find that list. Here it is. What I want to do for now is just take sunglasses and sunscreen. I'm going to cut those two lines. I'm going to come up here under hat and I'll put those up. Those are pretty important items to remember to bring. So I'm going to move them up higher in the list. Okay, so now let's come over here. If we type git status in our command line, we can see the changes, and git diff will show us that sunglasses and sunscreen were moved from lower down to higher up. Let's make that commit. Git commit -a m, and let's just say changed items to bring. Okay, so now I have git status, working tree is clean, git log. You see changed items to bring is there. That's my most recent commit. Notice also that its SHA that it generated is ED42835, etc. Now let's make a change to that. Let's say I say, oops, you know what? I forgot to make a change there. Instead, I want to take insect repellent, and that should also go up higher. So let's cut that one, and I'll move it up here under sunscreen. I'll come back over here. Let's say git status. You can see the changes there. Git diff shows me the change. Now, I want to include that change in with my previous changes. So right now, it's not staged. Let's go ahead and stage it, add, and it's going to be resources.html. Git status will show that it's now staged. If I want to amend the previous commit, then I can say git commit space -- amend. Amend is going to amend it with this new information. It's going to take what's in staging and add it to that commit. Okay, so let's say git commit amend, and then we'll go ahead and do another message. Our message this time will be reorder recommended items for trip. Now, if I say git log, the old commit is gone. My new commit is there. It has reordered recommended items for trip. Notice that the SHA has changed. It's now different. And if I copy that SHA and I do git show, you see what's in it. It has all of those changes in there. So I was able to edit it by using amend. Let's say that I just said, you know what? That message wasn't a great message. I'm going to hit the up arrow, git commit -- amend with my message. And it says reorder recommended items for outdoor trip, right? I just made a simple typo maybe in my commit message. Okay, now let's take a look. Git log, reorder recommended items for outdoor trip. Notice the SHA changed, even though the only thing I did was change the commit message. It has a different SHA now, but if I take a look at that SHA, let me just copy that, git show, you can see it has the same set of changes inside of it. So that's it. That amend option that you use with commit says, take whatever was in the old commit, bring it back down to staging, add whatever staging has into it, and then let's recommit that. I'm going to amend it with those new changes. That's how you can think of it. It's taking what's in the last commit, bringing it down, adding your new stuff to it, and recommitting it and generating a new SHA in the process. In this movie, we'll talk about how to retrieve old versions of files. In the previous movie, we saw that Git only allows amending the most recent commit. And that's important because Git is trying to maintain data integrity along the chain of commits. And if it were easy for us to start editing the history of commits, then we wouldn't have that data integrity. We wouldn't be able to trust that nothing had changed. Instead, if we want to undo some changes that we've made, the right way to do it in Git is to make those edits into new commits so that it accurately reflects what happened. Let's say we changed a word from singular to plural, we make a commit. Then if we want to change it back from plural to singular, then we should make another commit. It may have been days or weeks since that change happened, or it may have happened recently. But we want to reflect the fact that two different commits were changed, even if what's happened is that we've just changed our mind. We don't need to have it be nice and tidy. Instead, we want that data integrity. Now, sometimes it is helpful for us to be able to retrieve an old version of a file, to go back into our commits, to find out what a file used to look like so that we can then revert back to that older version or something close to it. In this movie, I want us to learn how to do that because it's a helpful technique. If we type git log, then you'll see that the second commit here is changes title of Explorer's page. I'm going to hit quit, and then let's just do git show and take a look at that SHA, 6794C13. So there's the change, nice and simple. Let's say that I want to make another change to that. Now, I don't want to go back and try and change this commit. That's a snapshot that's locked in time and it's in the chain of commits. So what I want to do is make a new commit that is based off of this in some way. So let's pull up that old file. Let's grab the old version of this file, and then we can make changes from there. So once again, I'll use git log. Let's look at the list of commits. What I'm really asking for is I want to know what this page, the Explorer's page, looked like before that change was committed. So that's the commit that's before it. So I'm just going to grab the first part of this SHA and copy it. That's the commit that I want to reference. I want the Explorer's page as of that moment in time, when the head pointed to that commit. So I'll hit Q to exit out of the log. I'm going to clear my screen, and let's type git checkout. Remember, we used checkout before. We used it to undo changes in our working directory. This time, though, I'm going to give it the commit. Git checkout from this commit, and then a space, and then I'm still going to use that bare double dash that says on the current branch. Don't go to a different branch. So this commit, this revision from the current branch, and the file that I want is going to be explorers.html. I'll hit return. Now when I type git status, you'll see that it has put that into my staging directory. Not just in my working directory, it's in my staging. So my working directory has it, but so does staging. If I say git diff staged, you can see the changes, and you can see that the change is to revert things, right? It takes what it was in the repository. The repository version now says make new friends. I'm going back to the old version, come make a few friends. Let's take a look in our code. Let's look at explorers.html, scroll down a bit, and here it is, come make a few friends. You see the old version has now been put into my working directory and into staging. So this is essentially undoing it. So now I could change this. Let's say I want to make it into make a few new friends instead. Okay, so now git status. Now there's some changes that are in my working directory that are not in staging. Git add and explorers.html will add it. Git status. Oops, sorry, didn't type quite enough. Git status. Now it's in there. Git diff staged. You can see the change. You can see what it's going to do. It's going to go from my second version of this into a third version, right? Something different. And then we could commit that, and then we would have both sets of changes logged. That's the better way to undo or revise previous changes, is to make a new commit. Now I'm not going to commit these yet. Instead, I'm going to use get reset head with explorers.html and then get status. You'll see that it's there. I need to do get checkout -- explorers.html and now get status, and everything is clean again. And the reason why is because in the next movie, I want to show you a shortcut for when you just want to revert a commit. We've been looking at different ways that we can undo changes after we've made commits to our repository. In this movie, I want us to learn how you can revert a commit. Reverting a commit essentially means to just undo it, to do the opposite, to go backwards. If you made changes A, B, and C, then it undoes changes A, B, and C. Let's take a look at our Git log. And in the last movie, we're looking at the changes to the title of the Explorers page here. I'll copy that SHA. Let's do git show. You can see we just simply changed the H1 from come make a few friends to make new friends. Now we've decided, you know what? That was a mistake. We should not have done this. We want to now revert this commit back to what it used to be. Just go backwards, undo the change. We don't want to go in and make edits to this commit because it's now part of a chain of commits, and Git doesn't want us to make changes once things are in the history and part of that chain, unless it's the very last commit on the chain. So instead, we're going to make a new commit that simply reverses it. We could do that by hand. We saw how to do that in the last movie, but I want to show you that there's an even easier way. If we use git revert and then the name of the SHA, and that's the SHA that's up here, paste that in. The editor opens up. It has revert changes title of Explorers page. So it's our old message. It's letting us know that it's reverting whatever was in the old message. And it also tells us this reverts commit, and it gives us the SHA that's being reverted. So it's a nice, good way for us to know what is it that's being changed, right? It gives us the title and the SHA so we can go find it, look up more information about it. You can add more information to this message if you want, but I'm going to save it and just close it. That's a perfectly good message. Come back over here, and you can see that it's been committed now. Now, if we go look at our code, you can see it's back to come make a few friends. It's been changed back. If we look here, get status, the working tree is clean, get log. Now, here is this commit, changes title of Explorers page. You see it's SHA right here. And now we have a new commit that reverts that one. So we've essentially undone the changes. And if we take a look at both of these, let's use git show. And let's just do this one first. You can see it's changed. And let's do git show head. And that'll show the most recent commit. You see it goes the opposite. See, come make a few friends to make new friends. This one went from make new friends back to come make a few friends. This also is a good demonstration of why it's important to make your commits atomic, because then it's very easy to just revert a change. If this had been a commit that had 50 different things in it, then I could not have reverted one single part of it. I would have had to have extracted just the change that I wanted to make and made only that change. By making it atomic, I can essentially say, you know, all that set of changes I did, I want to undo them all now in one simple step. Git revert is the command that makes that easy. In this movie, I want to talk about another type of action that we can undo, and that is to remove untracked files from our repository. Sometimes files end up getting added to the repository that we don't want there. They might be compiled code, they might be log files, maybe it's just a bunch of extraneous stuff that somehow ended up getting added as we were working with our project. We could go through and remove those files by hand, one by one. But Git also allows us to just simply remove them all at once. It's a technique that can come in handy sometimes. Let's begin by adding some junk files to our project. So I'll just add a new file. I'm going to call this one junk.txt. And let's say it is junk inside of it. Actually, let me change the name here. Let me rename the file to be junk1, just so that we can have a couple of these. Let's make another new file. This one will be called junk2.txt. It'll also just say junk inside of it. And let's add a third one, new file, junk3.txt. Okay, so I've got these three files now. I'll close them all up. You can see that they're ready to be added. If we come over here, get status, they are currently untracked files. Now, let's say we don't want these files. We don't want to track them, and we don't want to remove them by hand. Now, removing them by hand would be a good way to hang on to them if we needed to keep them for some reason. But if we don't, if we really just essentially want to trash them forever, then if we type git clean by itself and hit return, it will not do anything. And that's because it needs one of these other options. I for interactive, -N or -F. Now don't worry about interactive. That'll just walk you through the steps. -N is essentially what says, let's do a dry run. Let's try this out. Let's see what would happen if I were to actually run it. -F runs the command. It forces it to clean the files. And it's just a little extra precaution because it is a very destructive action. So git clean with -N says would remove junk 1, 2, and 3. Tells you what it would do, but it doesn't actually do it. Now I just want to show you, if we add junk 1 to our staging directory, git status. So here it is. It's now in the staging tree, junk1.txt. Now, if I were to run clean -N, it would not remove junk 1. That's because it's removing everything that is untracked, meaning that it is not in the repository or in the staging tree. It's in my working directory only. Git is not tracking it. But Git has already started to track junk 1 a little bit. It's in the staging tree at least. So because it's in the staging tree, it's not going to allow it to be flushed. Now let's try running git clean with the -F option. Now it removed those two items. If I do git status, you'll see there's only junk 1 still in my staging directory. Git reset head and then junk 1 will now remove it. Git clean -N tells you that it would be removed. And if I use the F option, it actually removes it. Again, this is a destructive process. These files are now gone. They don't exist in my trash. They're nowhere located on my hard drive. They've been removed. So use it with caution. But if there are a lot of files that you want to just simply remove from your repository, git clean can be a useful tool to help you do that. As we've seen in previous chapters, Git does a good job of noticing when new files are added to the working directory or when files that are in the repository are changed in our working directory. But that's not always desirable. What if we don't want to track those changes? What if it's a temporary file that we don't care about? Or if it's a log file that's constantly changing? Instead of having Git always bother us about these files, we need a way to just tell Git to ignore them. If you create a file and put it in the root of your repository called .gitignore, then Git will read this file and use its rules when looking at the other files to decide what should be tracked and what should not. Changes made to ignored files will be ignored by Git. So we need to learn a little bit about the kind of rules that we can put in these files. The simplest thing is just to put a simple name of a file, and that file would get ignored. But we can also use pattern matching, basically simple regular expressions, like asterisk, question mark, character sets like AEIOU, or ranges like 0 to 9. So for example, if we want to ignore all files in the logs file directory that end in .txt, we can do that with logs/ and then the wildcard asterisk .txt. You can also use negative expressions. For example, we could say ignore all files that end in .php, but do not ignore index.php. If you want to ignore all files in a directory, then you can just use a trailing slash after the name. So assets/videos/ would ignore all files that are in that directory. You can also put comments in the gitignore file. So you can just put a pound or hash sign in front of any text that you want it to just be a comment in the gitignore file. Maybe you want to provide the reason why you ignored something. And any blank lines are simply going to be skipped. Let's try an example so you get the feel for it. So inside my repository right now, my working directory is clean. Let's add a file to it that's going to be a temporary file. Let's go into our text editor. Let's just add a new file here in the root, and let's call it access log. I'm going to save that file. I'm going to close it up. The idea is this file is just a temporary placeholder. What I'm thinking of is that this is the kind of thing that a web server might log all of the access to the website in this file. So it'd be a constantly changing file. We would always have changes to it every time we came to Git. We don't want to commit those changes to the repository. They're not important for us to keep track of. So instead, I just want to tell Git to ignore this file. So in order to do that, I'm going to make another file in here. And that file is going to be called .gitignore. And inside that file, I'm just simply going to put one thing, which is access.log. Then I'll save it. We'll come back over here and we'll type git status. Now this time it says, oh, I see a new file, but the new file is git ignore. It's not telling me about access log anymore. Access log is being ignored. So we could add our git ignore file. It would then be part of our repository, and anyone checking out our repository or working with it would also ignore the access log. Before we commit that change though, let's come over and just add a few others to this. So in addition to access log, let's say this is demo example, and that's a comment. We know that because it has the pound sign in front of it. Empty lines are going to be ignored, so I can skip down a line. And on the Mac, you sometimes get .ds_store files showing up. We don't want to track those. In addition, I'm going to say anything that's a .zip file or anything that's a compressed GZ file, anything that's in the log directory. I don't have a log directory here, but let's imagine that I did. And anything that's in there that ends in .log would get ignored. Anything that ends in .log and also a number 0 through 9. That happens sometimes if you have something rotating your log. So you have log 1, log 2, log 3, and so on. Let's imagine that we also had an assets directory, and in there was another folder called Photoshop files. We don't want to keep those in our repository, maybe because they're such large files and it's not really meaningful for us to track them. Same thing for assets/videos. All files that are in that directory would be ignored, except if we have assets/videos/tour underscore with any number, MP4, those will be kept. Okay, so that's going to give me just a group of files. Some of these are imaginary. It doesn't matter if they exist or not. It's a list of rules that Git will use to know what to track and what not to track. So let's save it. Come back over here. We'll type git status. Still, it's that same git ignore file. So let's go ahead and just add that git commit -a. We'll add a message, add.git ignore file. So now my git ignore file is there. Oops, I forgot to add the file. It did not actually make my commit. If we do git log, you'll see nothing got logged. And the reason why is because I forgot to add it first. Git ignore, it was an untracked file, and git commit with the -a option does not include new untracked files by default. So git status, now it's been included, git log, there's that git ignore file. Now my access log is still there, but it's not going to bother me about it. It doesn't matter if I make changes to it. This is an edit, save it, come back, git status. You see, it just ignores all of those changes. What you ignore inside your Git projects is going to be up to you, and it really depends on what kind of project you have and the kinds of files that are in it. But in this movie, I want to give you some ideas on the kinds of things that typically get ignored to help you out. The first is that you probably want to ignore compiled source code. Uncompiled source code is mostly what you want to keep track of. Compiled versions of the source code often aren't as useful. Same thing for packages and compressed files. The uncompressed files have code that you can look at and you can examine and track the changes. If it's compressed, then it's really a very opaque box that you can't see the changes inside of. Logs and databases are good to ignore because they're changing frequently. Most of the time, it's not useful to include them in your project. And operating system generated files. These are files that the operating system may add to your project in order to allow it to do its work, but they're not essential to the project. And last is user uploaded assets. Images, PDFs, videos that users of your system are adding into the project that aren't part of the core project itself, the code that makes it work. Those user uploaded assets are going to change over time, and they're not that important for you to keep another copy of. One very useful resource is that GitHub has a collection of useful git ignore templates. If you go to github.com/github/gitignore, you can browse them. Let's take a look. Here I am on that page, and if you scroll down, you can see that there's a list of all of these different git ignore packages, and they're grouped by their use. So for example, if you're using cake PHP, here's a cake php.gitignore file. If we scroll down a little further, if you're using Fortran, here's a good gitignore file for you. If you're using Go, here's one. You can just go on down and find things that look interesting to you. Let's scroll on down here till I finally get to Perl 6 gitignore. Let's take a look at that one. There's only two things listed here, precompiled files, .precomp and lib precomp. right, let's hit the back arrow. Let's take a look at Python. Python has a bit more. There's some distributed and packaging ones. So you can just take this file, drop it into your project, and you'll be ignoring a lot of the recommended files. And then you can tailor it to your needs. You can remove things from there. But it's a good starting point for any project. And as you can see, they have a wide variety of project types covered. We've been talking about ways to ignore files in Git. I want to talk about how you can globally ignore files. So far, we've been looking at how we can ignore files inside a project. But what if we want to ignore the files in all repositories? So if we have 4 or 5 different projects, we always want to ignore certain files in all of those projects. To do this, we need to set the ignore file globally, so that the settings are not tracked in a single repository. They become user-specific instead of repository-specific. The way we do that is by using the git config command that we learned earlier with the global setting, and then you set a value for core.excludes file. You're telling it what file it should use for exclusions. That file can be called absolutely anything you want. For example, you could call it gitignore_global, and you can make it a dot file so it doesn't normally show up. So that file can live anywhere you want, but a good place for it is in your user directory, since it is a user configuration. So that means that when you're logged in as that user, Git will use that config file to ignore files for any repository that that user is accessing. The way you handle your git ignore files is really up to you. I tend to put mine in each project specifically, and that way they become part of the repository, and when someone else shares it, they get those same git ignore files as well. But if there are files that you want to ignore that maybe other people don't, that should not be part of the repository, or if you find that you're ignoring the same files over and over and over again, you might find it better to set a global git ignore file. When we created a git ignore file earlier, Git ignored any untracked files that matched a rule in the git ignore file. However, it only applied those rules to untracked files. Files that are already being tracked are not ignored. Let's learn how to tell Git to ignore changes to files it is already tracking. Let me demonstrate it step by step. So first, let's see what the problem is, and let's add a new file to our repository. So I'll create a new file here, and I'm going to call that file db_config.txt, and I'm going to just put a basic sort of fake database configuration in here, project database, user, web, user. Okay, so I've got some configuration information. It's a new file. If we come over here, we see that new file, git add db_config, git commit with m, add database configuration file. Okay, so we've just done a basic commit of this file. So this file is now being tracked, right? If I make changes to it, then we know that Git is going to show us those changes. Let's now go into our git ignore file though, and tell git ignore that it should ignore this file. So right after access log, let's add db_config.txt, and let's save that file. Now let's come back over here and let's say git status, and we see that our git ignore file has been changed. Let's go make a change to dbconfig. So instead of this, let's add password : and we'll just leave it blank for now. We won't actually fill in a password. Let's come back over here and do git status again. And notice it did not ignore our file. The changes are still being listed there. So that's the problem that we're trying to solve. The fact that we've already tracked this file, Git doesn't use that git ignore on it. So how do we tell it not to track this file anymore? Essentially, how to start ignoring the changes that are there. It's a question that frequently comes up for beginners. Git ignore seems like it should be doing the trick, but Git wants to hold on and continue tracking these changes. I'll clear my screen. Now we know one way we could get rid of that file is just to remove it, right? Remove db_config.txt. Now if we did that, it would remove it from our project and it would add it to the staging index ready for us to commit, that the file would then be gone. And that's certainly one way to stop tracking it, right? Is to just get rid of it. But we don't want to remove it from our working directory. We want to keep this file there. What we want to do is remove it just from the staging index. And the way we're going to do that is tell git remove -- cached. You may recall that earlier I told you could use git diff with either staged or cached. They're synonyms. Well, here it's not a synonym. You have to use cached. So git remove the cached version of db_config.txt. Let's try it and see what happens. I hit return. It says it removed it. If I do git status, it's now listed as being deleted and ready to be committed. If we come over here, the file is still there. Our change still exists. If we do git diff on the staged version, you can see it's going to remove the file. That's what it thinks it's going to do. It's going to change it from a file to being not a file. Let's go ahead and commit these changes. Let's git add the git ignore file. That's added as well. Oops, I mistyped that. Git status. There we go. So you can see we've got two things about to be committed. Let's say git commit -m stop tracking changes to db_config.txt. Okay, so we've committed it. Now let's do git status again. Nothing to commit. And look at this. Our file is still here. Now let's change it. Let's say our password is secret. Save it. Come back over here. Git status. Nope, it's not tracking it. It didn't notice our changes. Now our git ignore is working. Now, of course, if we come back and we take that out of the git ignore file, git status, now it notices that there's this db config file that's untracked. But as long as we have it in our git ignore file, and as long as we've removed it from the cached version, then it no longer notices any edits that we make to that file. Now the file is still there. It is still in the repository. If someone new were to come along and check out a copy of this file, maybe from a remote repository like GitHub, they would still get the file in the version that we first committed it. The file does still exist, but future changes will not be tracked. In this movie, I want us to talk about how you can track empty directories in Git. Git is designed to be a file tracking system. So it tracks files and it tracks the directories it takes to get to files, but it ignores directories that have no files in it. Let me demonstrate. You may be surprised to realize that right now, Git is not tracking our Explorers file. Why? Because if I open it up, you can see that it's empty. The resources directory is being tracked because it has a file inside. How can we prove this? Let's come over here and let's just type in a command. This is a more advanced command you don't need to learn how to do, but I want to demonstrate with git ls-tree. It's listing the files in the tree. That's what it's doing. And I'm going to tell it to list everything that is at the head. So right at the last commit, what does the tree look like on Git? So it's going to list off a bunch of things here you don't need to worry about. But notice on this side, we have a list of files and directories. And it looks pretty similar to what we have over here. But notice that resources is listed, but Explorers, not Explorers HTML, but just Explorers, the directory, is not listed. That's because it's not being tracked. Git doesn't track empty directories. And if you want to further prove this to yourself, you can just go and create a new directory inside our project. Let's add a new folder. Let's call it temp. So now I have a temp directory. Let's come over here and let's type git status. And look, it didn't object. It says there's no changes. Nothing to commit. Now, most of the time, that's not a big deal. But sometimes you do want to have an empty directory in your repository. Maybe you want it so that when someone checks out the repository, there's a directory there that's waiting for some purpose. Maybe it's for users to upload images to. Maybe it's for log files. It could be for anything. But it's an empty directory that you want as part of the project. You don't want someone to have to create it. So how do we get to track these empty directories? Well, very simple. We make sure that they're not empty. The most common way that developers do that is by just adding a dot file into a directory that you want to be tracked. So let's say it's Explorers. Inside Explorers, let's create a new file and let's call it .gitkeep. That's the convention. To call it .gitkeep, I'm telling it I want it to keep this directory. So my text editor knows that it's a new file. I don't need to even put anything in it. I can just make it an empty file. And now when I say git status, Git recognizes that it is not empty. And it says, hey, I see a new folder called Explorers. Do you want to add that? Let's do git add Explorers, git status. There it is. New file is being tracked. Git keep. That's what it's going to actually commit for me. And let's commit it, git commit -m track Explorers directory. There it is. Now it's being tracked. Now if I make changes to it, those changes will be noticed. If someone checks out my repository, that directory will be there. The temp directory is still not being tracked. I want to show you one other thing. If you're on a Unix machine, one nice way to do this without having to go in and create it there is just to touch a file. You can just say touch temp and then .getKeep. And that touch command creates the file if it doesn't exist. If it does exist, then it just reaches out and touches it and updates its last modified time. But if it doesn't exist, it creates it. So let's just add it. There we go. Get status. And now you can see it wants to track temp as well. Now I'm not going to. Instead, I'm going to just remove that file. I'll come back over here and I'll just choose delete. Are you sure you want to delete it? Yes, I'll move it to the trash. And now get status isn't trying to track anything anymore. So that's it. If you want to track an empty directory, make sure it's not empty. And the best way to do that is by adding an invisible dot file called getKeep.